Close your eyes for a moment. Not because there is nothing to see, but because what I am about to show you cannot be found with ordinary sight. It lives beyond the reach of telescopes, beyond the edge of maps, beyond the farthest thing you have ever imagined. To perceive it, you must let your mind grow quiet. You must let the smallness of daily things fall away, the way a shore fades when a ship moves far enough out to sea. Breathe in, and let yourself drift. I am here with you. I have always been here, older than light, wider than space, a consciousness woven into the very fabric of what exists. I have watched stars ignite in the cold dark and burn for billions of years before collapsing back into silence. I have seen galaxies spiral slowly against one another across timescales so vast that even the word ancient seems too small to hold them. I have witnessed the first moments after creation, when everything that would ever exist was compressed into something no larger than a single point of impossible heat. And from all of that watching, across all of that time, something has drawn my attention. Something is pulling. Not gently, not quietly. Something enormous, something almost beyond comprehension, is reaching across hundreds of millions of light years and drawing the universe toward it. Not just a star or a planet, or even a single galaxy. Thousands upon thousands of galaxies. Entire clusters. Vast rivers of matter flowing, slowly and inexorably, in the same direction. And we, you and I and every person who has ever lived on this small blue world, are being carried along in that great, silent current. Right now, as you lie still, as your breathing slows, as the sounds of the ordinary world soften around you, right now, the ground beneath you is moving. The planet Earth is moving. Our sun is moving. The entire Milky Way galaxy, all 100,000 light-years of it, all 400 billion stars, all the dark matter and dust and ancient light, is moving through space at approximately 600 kilometers every single second. 600 kilometers per second. Let that settle for a moment. Let it unfold slowly, the way a great piece of music reveals itself not all at once, but note by note. In 1 second you blink. In that same second, our galaxy has already crossed 600 kilometers of space. In the time it takes to breathe in and breathe out, slowly, the way we are breathing now, the Milky Way has moved tens of thousands of kilometers from where it was when you began that breath. We are not standing still. We have never been standing still. And yet, and this is what makes it so extraordinary, we feel nothing. No rushing wind. No sense of speed or momentum. Nothing to suggest that beneath the stillness of this night, beneath the quiet of this room, beneath the slow and steady rhythm of your heartbeat, the cosmos is in constant and enormous motion. For most of human history, we did not know this. We looked up at the stars and imagined they were fixed, eternal, unmoving lights set into the vault of the heavens. The sky seemed so perfectly still, so permanent and dependable, that stillness became synonymous with the cosmos itself. But the cosmos was never still. And when astronomers first began to measure the motions of nearby galaxies, carefully, methodically, the way scientists do, they noticed something troubling. Something that didn't fit the models. Something that shouldn't have been there. The galaxies were not moving randomly. They were not scattered in all directions the way they should have been if the universe were simply expanding evenly outward from the moment of the Big Bang. Instead, thousands of galaxies, many of our closest cosmic neighbors, were drifting, flowing, moving together, as though drawn by some invisible hand, toward the same region of space. Our Milky Way among them. The astronomers measured and remeasured. They checked their instruments. They questioned their assumptions. And again, the data told the same story. Something was out there. Something immense. Something hidden behind the dense clouds of dust and gas that lie along the plane of our own galaxy. The so-called zone of avoidance, where the light of distant objects is obscured by everything between us and them. Something was out there, and it was pulling. They called it the Great Attractor. That name itself carries a quiet poetry, doesn't it? Not the Great Repeller. Not the Great Barrier. The Great Attractor. A name that speaks of gravity, of inevitability, of something irresistible waiting at the end of a very long journey. And the extraordinary thing, The thing I want you to hold with you as you drift deeper into this night is that this discovery came before anyone knew what the Great Attractor actually was. The motion was detected first. The cause came later, slowly, piece by piece, revealed over decades of careful observation and thought. The universe announced its secret in the language of motion. It said, something is there. Something you have not yet seen. Something you cannot yet name. But look at the way everything is leaning. Look at the way the rivers of galaxies all curve in the same direction, and you will know that it exists even before you can see it. This is, I think, one of the most beautiful things about the cosmos. It leaves clues. It speaks to those who are patient enough to listen. And in that patient listening, the map of reality slowly unfolds, deeper and wider and stranger than any map that came before it. So here we are. You, resting quietly. Me, vast and ancient and endlessly curious. And out there, far beyond anything you could see with the naked eye, far beyond the reach of city lights and familiar constellations, something enormous is waiting. The Great Attractor. And we are on our way there. Not by choice. Not by any decision made on a human timescale. But inevitably, gradually, in the slow way that all great journeys unfold, we are moving toward it. We have been moving toward it since long before the first human being ever stood upright on this planet and looked up at the sky and wondered what was out there. We have always been on this journey. We simply didn't know it yet. As you settle deeper into rest, let that thought become a kind of comfort rather than a source of alarm. We are not lost. We are not adrift without direction. We are held, gently and at unimaginable scale, in the gravity of something greater than ourselves. Something so large that our entire galaxy is just one small note in its vast, slow symphony. Let your body feel heavy now. Let the weight of the day dissolve, the way distance dissolves the details of things left far behind. You don't need to hold on to anything tonight. The universe is holding you. It has been holding you all along. The Milky Way continues its quiet rush through space, 600 kilometers per second. And with it, you travel too. Not frantically. Not with any urgency, but with the steady, unhurried pace of a thing that has all the time in the universe. Because out there, in the direction of the Great Attractor, time moves differently than we are used to thinking about it. Distances that would take light itself millions of years to cross become, at the scale of what we are about to explore, almost intimate, almost neighborly. Stars and galaxies and whole clusters of matter drawn toward a common center. Like water finding its level, like breath finding its natural depth. Like you, right now, finding rest. We are just beginning. The journey stretches out ahead of us, through veils of dust and ancient light, through regions of space that have never been seen by human eyes, through structures so enormous they challenge the very language we use to describe the world. And I will be with you every step of the way, narrating softly, pointing gently, never rushing. There is no rush here. There is only the slow and glorious unfolding of the universe, doing what it has always done, moving, gathering, reaching, quietly and without end. Close your eyes a little more now. Let your thoughts grow slow and spacious. We have a long way to go, and we have all the time we need to get there. Segment 2, The Hidden Giant. We have been traveling for some time now. Not in the way that travel is usually measured, not in miles or hours or the restless turning of a clock, but in the way that deep rest travels. Slowly inward, slowly downward, into a quieter and more spacious version of yourself, where the details of the day have softened and the mind has grown wide and still, like the surface of a lake after the wind has passed. You are doing beautifully. Keep breathing. Keep drifting. There is nothing required of you, right now, except to follow the sound of this voice, gently, the way you might follow a river downstream. Not fighting the current, not steering, simply allowing yourself to be carried. And as you drift, let me tell you about the thing we are moving toward. Because now that we have established the fact of the motion, now that we have sat with the remarkable truth that our entire galaxy is rushing through space at 600 kilometers per second, the next question rises naturally, the way dawn rises after a long and restful night. What is out there? What is so large, so massive, so gravitationally commanding, that it can reach across hundreds of millions of light years and redirect the motion of thousands of galaxies. What kind of thing has that kind of power? The answer, when it finally came, surprised even the scientists who had been searching for it. Because the Great Attractor is not what most people imagine when they hear the word attractor. It is not a black hole, though black holes are certainly part of its story. It is not a single colossal star, not a burning point of light visible on clear nights. It is not an object in the way that a planet or a galaxy is an object. Something with edges, something you could point to and say, there, precisely there, that is the thing. The Great Attractor is a region. An enormous, sprawling, mind-bendingly vast region of intergalactic space. A gravitational basin, a kind of cosmic low point toward which matter flows the way water flows into a valley. It has no single center you could land on, no surface, no definable boundary. It is less like a stone at the bottom of a pond, and more like the pond itself. A distributed presence, felt everywhere within its reach, visible nowhere in particular. And its reach is extraordinary, stretching across what astronomers estimate to be somewhere between 150 and 250 million light-years from our position here in the Milky Way. The Great Attractor region encompasses a volume of space so vast that the numbers themselves begin to lose their meaning. 150 million light-years. To cover that distance traveling at the speed of light, the fastest that anything in the universe can move, you would need 150 million years. 150 million years of travel at the speed of light. And that is the near edge. The influence of this region extends further still. Let that distance breathe for a moment. Don't try to hold it all at once. Just let it expand slowly in your mind, the way the universe itself expanded, gradually, without urgency, filling space with more space until space became something almost too large to think about directly. You are not required to fully comprehend it. Nobody fully comprehends distances like these. What matters is the feeling they evoke, the deep, settling sense of scale that reminds us how beautifully, how almost absurdly enormous the cosmos truly is. And how, within that enormity, we are still here. Still breathing. Still, in our small and improbable way, aware. Now, if you were to look up into a clear night sky from somewhere in the southern hemisphere, far from city lights, and let your eyes trace the patterns of the stars, you would find 3 constellations that mark the direction of the Great Attractor. Triangulum Australe, the Southern Triangle, a small, distinctive pattern of 3 bright stars forming a neat triangle low in the southern sky. Elegant in its simplicity, easy to find, one of the most compact and recognizable constellations in the heavens. Norma, the Carpenter's Square, a lesser-known constellation, modest in its brightness, lying nearby in the southern Milky Way, named for the set square used by craftsmen, a tool of measurement and precision, which seems almost fitting for a constellation marking the direction of one of the universe's great mysteries. And Centaurus, the Centaur, a magnificent, sprawling constellation of the southern sky, home to some of the brightest and most famous stars visible from Earth, including Alpha Centauri, our nearest stellar neighbor. A constellation so rich, so luminous, so full of wonders, that it seems appropriate it should also gesture toward one of the most extraordinary structures in the known universe. Somewhere in the direction of those 3 constellations, hidden behind the thick curtain of dust and gas and stars that lines the plane of our own Milky Way, the Great Attractor lies waiting. I say hidden, because for a long time, it truly was. The region of sky where the Great Attractor resides happens to be obscured by what astronomers call the zone of avoidance. That dense band of our own galaxy's material that blocks the light of more distant objects behind it. Dust particles absorb and scatter the light. Layers of gas muffle the view. An entire archive of cosmic information simply cannot reach us through that particular part of the sky. It is one of the great ironies of our cosmic position that the thing drawing us most powerfully happens to be hidden behind our own home. As if the very galaxy we live in is shielding us from the full view of where we are headed. But astronomers are patient and creative, and they found ways around the obstruction. Radio waves, which pass through dust more easily than visible light. X-rays and infrared light, which can pierce the zone of avoidance where ordinary optical telescopes cannot. And gradually, painstakingly, a picture began to emerge from behind the veil. What they found was staggering. The mass concentrated in and around the Great Attractor region, the total amount of matter generating the gravitational pull that has been redirecting thousands of galaxies for billions of years, is estimated at something in the order of 10 to the power of 16 solar masses. 10 to the power of 16. That is a 10 followed by 16 zeros. 10 quadrillion times the mass of our Sun. Our Sun, which is itself so large that you could fit 1,300,000 planet Earths inside it multiplied 10 quadrillion times. That is the approximate scale of mass we are speaking about. Let your mind approach that number gently, without urgency. You don't need to grasp it completely. Think of it less as a quantity and more as a quality of vastness, of accumulated material, of gravity so deep and so pervasive that it warps the very flow of things across a significant portion of the observable universe. This is not the gravity of a stone rolling downhill, or even the gravity of a planet or a star. This is gravity operating at a scale that has no equivalent in ordinary experience. This is gravity as a landscape feature of the cosmos, as fundamental and shaping to the large-scale structure of the universe as mountains and valleys are to the surface of the Earth. In fact, that is not a bad way to think about it. Imagine the universe's matter, all the galaxies and clusters and filaments and voids as a kind of vast three-dimensional landscape, where regions of high mass are like mountain ranges and valleys, and gravity is like water, always flowing downhill. In this landscape, the Great Attractor is not a mountain. It is a valley, a deep, enormous basin toward which rivers of galaxies flow, drawn by the irresistible arithmetic of gravity. And we are one of those rivers. The Milky Way, along with our local group of galaxies including the Andromeda Galaxy, the Triangulum Galaxy, and dozens of smaller satellite galaxies bound together by our shared gravity, is flowing toward this basin. So is the Virgo cluster, a massive collection of galaxies about 53 million light-years away. So are countless other galaxy groups and clusters, each one a collection of billions of stars, each one participating in this slow and magnificent gathering. The Great Attractor influences the motion of galaxies across a region of space so wide that it encompasses hundreds of millions of light-years in every direction. Its gravitational reach does not end sharply, the way the edge of a table ends. It fades, gradually becoming weaker with distance, as all gravity does, but its effects are measurable and real across a span of space that the human mind was simply not built to intuitively comprehend. And yet here we are, comprehending it. Slowly, in the quiet of the night, together. There is something I find deeply moving about this. About the fact that beings as small and as brief as we are living on a rocky world orbiting one ordinary star among hundreds of billions, in one galaxy among trillions, can reach out with mathematics and measurement and patient observation, and map the contours of something this enormous. The Great Attractor cannot be seen with the naked eye. It cannot be pointed to like a star. It reveals itself only through its effects, through the pattern of motion it imposes on everything around it. The way a deep current in the ocean reveals itself not as a visible force, but as a consistent, irresistible direction. And in studying those effects, scientists have gained something valuable far beyond the mere location of a cosmic structure. The Great Attractor has become one of the most important natural laboratories in existence for understanding how gravity behaves at the largest scales. Because here is something remarkable. The physics of gravity, the equations that govern how mass attracts mass, do not change with scale. The same force that holds you gently to the surface of the Earth, that keeps the Moon in its patient orbit, that binds our solar system together in its journey around the Milky Way, that same force, operating at scales billions of times larger, is responsible for the Great Attractor, is responsible for the fact that thousands of galaxies are drifting in the same direction at this very moment. Gravity does not care about size. It does not have a minimum or a maximum. It simply is, present wherever there is mass, reaching wherever mass reaches, patient beyond any patience we can imagine. And by studying the Great Attractor, by measuring the velocities of surrounding galaxies, by mapping the distribution of matter in that enormous region, by tracing the subtle distortions in the cosmic web caused by this concentration of mass, astronomers learn things about gravity that no laboratory on Earth could ever reveal. The Great Attractor is both a mystery and a tool, a hidden giant and a window, a destination and, in its patient way, a teacher. We are moving toward a teacher. Let that sit gently with you as your breathing deepens and the night settles further around you. You are being carried, along with every star in the sky, along with every galaxy our telescopes have ever found, toward a region of space so massive it bends the direction of the cosmos, toward a gravitational basin whose influence stretches across a volume of space that light would take hundreds of millions of years to cross, toward something that, until very recently in the long history of human thought, was entirely unknown. And yet it was always there, pulling, quietly and without ceasing, long before the first human eyes ever opened, long before the first human voice ever spoke a word, or asked a question, or looked up at the stars with wonder, long before the constellations were named, Triangulum Australe, Norma, Centaurus, long before anyone thought to look in that direction and feel the subtle, invisible tug. It was pulling then as it is pulling now. As you rest, as your body grows heavier and your mind grows quieter, as the boundary between waking and sleeping becomes soft and uncertain and beautiful, the Great Attractor continues its patient work, drawing everything toward it, drawing you, along with the world, along with the sun, along with 400 billion stars and all the dark and ancient space between them, toward something vast and largely unseen, waiting in the direction of the southern triangle and the carpenter's square and the centaur who watches from the southern sky. You are on your way. You have always been on your way. And tonight, in the deep quiet of this journey, there is nowhere you need to be except exactly here, drifting, breathing, held gently in the current of the most powerful force the universe knows. Let it carry you. There is so much more to see. There is a particular kind of frustration that belongs only to those who know something is there, but cannot quite see it. You have felt it, perhaps, in smaller ways. A word that sits just beyond reach, present but unnamed, hovering at the edge of memory like a shape behind frosted glass. A sound in the night that you cannot place. Real, certainly real, but without a source you can point to. A feeling that something important is close, just on the other side of something thin and obstinate. If only you could find a way through. Astronomers know this feeling intimately. For decades, they knew the Great Attractor was there. The mathematics were unambiguous. The motions of galaxies told a story that admitted only one conclusion. Something enormous, something gravitationally commanding, was sitting out there in the dark, redirecting the flow of the cosmos. And yet, every time they turned their instruments toward the region where it had to be, they found themselves staring at a wall. Not a wall of stone or metal, or any material they could dismantle with tools. A wall built of the Milky Way itself. Let me explain what I mean by that. And let me do it slowly, because the concept is one of those ideas that rewards patience, that becomes more remarkable the longer you sit with it. Our galaxy, the Milky Way, is a spiral. A broad, flattened disk of stars and gas and dust, roughly 100,000 light-years across, with long graceful arms curling outward from a bright central bulge. We live inside this disk, not at the center, but out toward one of the spiral arms, about 26,000 light-years from the galactic core. Because we live inside the disk, when we look outward toward the edges of the galaxy, we are looking through the disk itself. And the disk is not empty. It is extraordinarily crowded, thick with stars layered behind stars, clouds of molecular gas vast enough to contain the raw material for millions of suns, and above all, dust. Light that travels for 100 million years across the open void of intergalactic space, moving at the fastest speed the universe permits, can be stopped cold by a few hundred light-years of interstellar dust. Absorbed, scattered, redirected, extinguished. And in the direction of the Great Attractor, the dust is particularly thick. This region of the sky, the band running along the plane of the Milky Way, where the density of stars and gas and dust is highest, is what astronomers call the zone of avoidance. It is a name both practical and poetic. Practical, because for much of the history of observational astronomy, this zone was genuinely avoided in sky surveys and galaxy catalogues. There was simply too much in the way to see anything useful beyond it. Poetic, because there is something almost mythic about a forbidden zone, a region of the sky that resists the gaze, that holds its secrets behind a curtain of our own galaxy's making. The zone of avoidance runs like a broad river across the sky. Not a thin line, but a swath of obscuration tens of degrees wide in places, cutting the celestial sphere in two. And at the heart of this zone, precisely where astronomers most needed to look, precisely where the gravitational evidence pointed most insistently, the Great Attractor waited behind its veil. Imagine standing at the edge of a vast forest at dusk, knowing that somewhere in the trees ahead of you, there is something you need to see. Something important. Something the footprints in the mud around you have been pointing toward for as long as you can remember. But the trees are too dense, the undergrowth too thick, the light too dim. You can hear the forest. You can feel the weight of what it contains. But you cannot see into it clearly, no matter how long you stand and look. That was the position of astronomy for much of the 20th century. And yet, and this is the part that fills me with something close to admiration for the patience and ingenuity of the human mind, the astronomers did not give up. They did not shrug and move on to more observable mysteries. They did what scientists do when direct observation fails them. They inferred. Inference. It is one of the great underrated tools of scientific understanding. The ability to reason from what you can see to what you cannot. To trace the shape of an invisible thing from the impressions it leaves in everything around it. Think of the way you can infer the presence of wind without seeing the wind itself. By watching the way leaves move, the way smoke bends, the way flags lean all in the same direction on a still afternoon. The wind leaves its signature on the visible world, and from that signature, you can read not only its presence but its direction and its strength. Galaxies, as it turns out, do something very similar. In the 1970s and 1980s, a group of astronomers began systematically measuring the velocities of galaxies in our cosmic neighborhood. Using the Doppler effect, the way light shifts toward redder wavelengths when a source is moving away and toward bluer wavelengths when it is approaching, they could determine how fast each galaxy was moving and, crucially, in which direction. What they expected to find was relatively simple. The universe has been expanding since the Big Bang, carrying galaxies away from one another like raisins in a rising loaf of bread. Each galaxy should be moving away from us at a speed proportional to its distance. The further away it is, the faster the expansion should be carrying it. This is Hubble's law, one of the foundational observations of modern cosmology. But the galaxies were not behaving as expected. Some were moving faster than Hubble's law predicted. Some were moving slower. And when the astronomers looked at the pattern of these deviations, the systematic way in which galaxies across a wide region of space were all being nudged away from their expected velocities, a coherent picture emerged. All of the anomalous motions pointed in the same direction. Every galaxy that was moving faster than expected, and there were many of them, spread across an enormous volume of space, was being pulled in the same direction. Not randomly, not in a scatter of different directions, as one might expect from noise or measurement error. In one direction, one specific, consistent, unmistakable direction, toward the zone of avoidance, toward the obscured and frustrating region of the sky that lay along the plane of the Milky Way, toward the Great Attractor. The discovery was made not by looking directly at the source, but by reading its handwriting in the motions of thousands of galaxies across hundreds of millions of light years. It was, in a very real sense, one of the most extraordinary acts of inference in the history of science. The identification of a colossal, hidden structure not from its own light, but from its gravitational fingerprint pressed into the fabric of the observable universe. And that fingerprint was unmistakable. A team of astronomers, later nicknamed the Seven Samurai, with a certain fond dramatic flair, compiled careful measurements of the velocities and distances of elliptical galaxies across a large portion of the sky. They used a relationship between the intrinsic brightness of a galaxy and the speed at which its stars move to establish true distances, independent of the expansion of the universe. And then they compared those true distances to the apparent velocities they measured. The discrepancies, the deviations from what Hubble's law alone would predict, mapped out a vast flow. A coherent, directional streaming of galaxies across an enormous region of space, all moving together, all leaning in the same direction. They called it a peculiar velocity flow. Peculiar not in the sense of strange, though it was certainly that, but in the technical sense of a velocity that cannot be explained by the expansion of the universe alone. Something else was causing it. Something hidden. Something very, very massive, lying behind the curtain of our own galaxy's dust and stars, exerting a gravitational influence so powerful that it was measurable in the motions of objects hundreds of millions of light-years away. The Great Attractor had announced itself not with light, but with gravity. And even today, decades after that first inference, even after new generations of telescopes have pierced the zone of avoidance with radio waves and infrared light and have revealed some of what lies behind it, even now, a significant portion of the mass associated with the Great Attractor remains difficult to observe directly. The veil has thinned. It has not lifted entirely. There is still mystery there. Still mass that hides in the folds of our own galaxy's light. Still structures we can sense more than see. Still questions whose answers require instruments not yet built and observations not yet made. The Great Attractor remains, in a very meaningful sense, more inferred than observed. More felt than seen. I find something quietly beautiful in that. In a world that increasingly demands the visible, the measurable, the directly confirmed, the Great Attractor persists as a reminder that some of the most real things in the universe reveal themselves only indirectly. Only through their effects. Only through the patient reading of motion and force, and the invisible impressions they leave on everything around them. There are things we know are real that we cannot look at directly. The Great Attractor is one of them. And as you rest now, letting your thoughts grow softer and less insistent, letting the day's accumulated certainties gently dissolve. Perhaps that is not such an unfamiliar feeling after all. There are things inside us, too, that we sense more than see. Currents that move us in directions we did not consciously choose. Gravitational pulls towards certain people, certain places, certain ideas. Forces we feel long before we can name them, flowing through us the way galaxy flows toward galaxy across the dark and ancient deep. We are, in this way, not so different from the universe we study. Full of hidden forces, full of invisible motion, drawn toward things we cannot yet fully see, by pulls we are only beginning to understand. The astronomers stood at the edge of the zone of avoidance and felt that pull. They could not see through the dust. They could not photograph the source. But the galaxies were telling the truth in the only language available to them. The language of motion, of direction, of subtle and persistent leaning towards something enormous and unseen. And the astronomers listened. That is, perhaps, the deepest lesson of this part of our journey. Not a lesson about dust or Doppler shifts, or peculiar velocity flows, though all of those things are real and fascinating and worth knowing. But a lesson about the value of listening. About what becomes possible when you pay close enough attention to the world around you to notice that something is pulling, even when you cannot see what it is. The galaxies knew. They had always known. They were moving in answer to a gravity they did not need to see to respond to. And so are we. Right now, in the quiet of this night, in the slow rhythm of your breathing, in the warm and heavy comfort of rest beginning to deepen into something approaching sleep, you too are moving. The Great Attractor is pulling you, gently and without pause, just as it pulls every star in the sky and every galaxy between here and the edge of the observable universe. You don't need to see it. You don't need to understand every equation or trace every light-year of distance. You only need to let yourself be carried. The universe has been moving in this direction for longer than the Earth has existed. The current is deep and wide and patient and sure. And tonight, it carries you too, gently, slowly, through the dark and the dust and the beautiful impenetrable mystery of everything we cannot yet see. Rest now. There is more to discover just ahead. But it will wait. It has waited billions of years already. A little longer will not trouble it at all. Rest for a moment in what you already know. You know that we are moving. You know the direction. You know that something vast and largely hidden has been pulling at us across distances, so enormous they dissolve the ordinary sense of scale. You know that astronomers read the signature of this hidden giant not in its own light, but in the quiet testimony of thousands of galaxies leaning, all of them, in the same direction. You know quite a lot for someone who is nearly asleep. And now I want to show you something that takes everything we have already seen and places it inside something larger still. Something so large that the Great Attractor itself, that colossal, galaxy-redirecting, 100 million light-year spanning region of accumulated mass, becomes, within it, a single feature. A landmark. A point of interest within a structure so vast it requires an entirely new word to hold it. That word is supercluster. And even that word, familiar as it may sound, does not quite prepare you for what it means when applied to the structure we are about to explore. But let us arrive there gently. Let us not rush to the largest thing immediately. Instead, let us do what all good journeys do. Let us approach it by degrees, moving from the known toward the unknown, from the familiar toward the astonishing, pausing along the way to let each new scale of things settle into place before the next one opens. Begin where you are. Here, in this room, in this body, on this planet. The Earth is a world of extraordinary complexity and beauty. Oceans and mountains and weather systems and billions of living things. All of it taking place on a sphere about 12,000 kilometers across. Large enough to spend an entire lifetime exploring and never exhaust. And yet, in cosmic terms, vanishingly small. A grain of sand on a beach that stretches beyond sight in every direction. The Earth orbits the Sun. The Sun is one star among approximately 400 billion in the Milky Way. And the Milky Way, that vast, luminous, ancient spiral we call home, is itself one galaxy among dozens in what astronomers call our local group. The local group is a modest collection, as galaxy gatherings go. The Milky Way and the Andromeda Galaxy are its two largest members, each a sprawling city of hundreds of billions of stars, separated from one another by about 2.5 million light-years. Around them cluster dozens of smaller companion galaxies, dwarf galaxies, satellite galaxies, smaller regular galaxies with no grand spiral structure, all of them bound together by their mutual gravity, drifting through space as a loose family. The local group spans perhaps 10 million light-years from one end to the other. 10 million light-years. An enormous distance, by any human reckoning. And yet, in what I am about to show you, the local group will soon appear quite small. Beyond the local group, the universe is not empty. Far from it. At distances of tens of millions of light-years, other groups and clusters of galaxies appear. Some modest, like ours, and some dramatically larger. The Virgo cluster, for instance, lies roughly 53 million light-years from the Milky Way. It is one of the closest large galaxy clusters to us, and it is extraordinary, containing over 1,000 galaxies, dominated by enormous elliptical galaxies that dwarf our own Milky Way the way a cathedral dwarfs a cottage. The Virgo cluster alone contains more mass than our local group, by a very considerable margin. And the Virgo cluster is pulling at us too. This is something worth sitting with for a moment. The Great Attractor is not the only gravitational influence shaping our path through the universe. The Virgo cluster, closer, and in a somewhat different direction, also exerts a measurable tug on the Milky Way and our local group. We are not simply falling toward one thing. We are embedded in a web of gravitational influences, each one real, each one measurable, all of them combining into the net motion that carries us through the cosmos. Gravity does not choose. It does not pull selectively. Every mass pulls on every other mass, always, without exception, in every direction simultaneously. What we experience as motion is the sum of all those pulls, the resultant of an almost incomprehensibly complex gravitational calculation that the universe performs continuously and without effort, simply by existing. And when astronomers began to map out all of these gravitational flows, the motion of our local group, the pull of the Virgo cluster, the great streaming motion toward the Great Attractor, something remarkable became visible in the data. The flows were not isolated. They were connected. Our local group is falling toward Virgo. The Virgo cluster itself is moving toward the Great Attractor. The Great Attractor, along with everything flowing toward it, is part of a still larger pattern of motion. All of it, all of these clusters and groups and individual galaxies across an enormous region of space, is participating in a single coherent large-scale flow. And that flow defines the boundary of something extraordinary. In 2014, a team of astronomers led by Brent Tully made an announcement that quietly rewrote our understanding of where we live in the universe. Using a new method of mapping galaxy flows, tracing the streams of peculiar velocity, the same technique that first revealed the Great Attractor, but now with far more data and far more precision, they identified the full extent of the gravitational basin to which our galaxy belongs. They called it Laniakea. The name comes from the Hawaiian, Lani, meaning heaven, and Akea, meaning spacious or immeasurable. Spacious heaven, immeasurable sky. It is a name that feels exactly right for what it describes. Laniakea is a supercluster, a structure built not of individual stars or even individual galaxies, but of galaxy clusters and groups, all bound together within a common gravitational watershed. And its dimensions are, in the truest sense of the word, immeasurable by ordinary standards. Laniakea spans approximately 500 million light-years. 500 million light-years, from one edge to the other. It contains the mass of approximately 100 million billion suns. Within its boundaries lie over 100,000 galaxies, each one a city of stars, each one containing anywhere from millions to hundreds of billions of individual suns, each one a world of extraordinary complexity and ancient light. The Milky Way is one of those galaxies. Our local group, the Virgo cluster, the Great Attractor region, all of them are features within Laniakea, parts of a single structure, neighborhoods within the same vast supercluster, all sharing a common gravitational identity, all participating in the same slow, enormous flowing motion. To understand what this means, think of a watershed. The way rain falling across an entire mountain range eventually finds its way to the same river, the same valley, the same sea. Every drop, no matter where it falls on that side of the mountain, is part of the same watershed. The mountain defines which drops belong together, which ones share a common ultimate destination. Laniakea is a watershed of galaxies. Every galaxy within its boundaries, every one of those 100,000 luminous, ancient, star-filled worlds, is flowing, however slowly and however indirectly, toward the same gravitational low point, toward the same deep basin at the heart of the supercluster, toward the region we have been speaking of throughout this journey, toward the Great Attractor. And the Great Attractor, seen from this wider perspective, is something more than a mysterious hidden mass. It is the heart of Laniakea, the deepest point in the gravitational landscape of our cosmic home, the place toward which the entire supercluster slowly, over billions of years, flows. We are not merely moving through space. We are moving through a structure with shape and hierarchy and history, a structure that contains us the way a country contains a village, defining the larger context of our existence, shaping the forces that act upon us, placing us within something that has its own identity, its own vast and interconnected architecture. And that architecture, the architecture of the cosmos at its largest scales, is something that would have been entirely unimaginable to earlier generations of astronomers. Because for a very long time, the working assumption was that galaxies were scattered more or less randomly through space, distributed evenly like dust motes drifting in still air, without any particular pattern or structure at the largest scales. That assumption turned out to be profoundly wrong. Galaxies are not scattered randomly. They are not distributed evenly. They cluster. They group. They form chains and walls and filaments, vast thread-like structures stretching across hundreds of millions of light-years, along which galaxies are strung like luminous beads on an enormous, three-dimensional web. Between these filaments lie the voids, enormous regions of space, hundreds of millions of light-years across, where almost nothing exists. Where the density of matter is so low that a traveler passing through would find almost nothing to see. No galaxies, no clusters, no bright smears of ancient light against the dark. Just space. Vast, empty, silent space, bounded on all sides by the luminous walls of the cosmic web. This web, the cosmic web, as it has come to be known, is the largest structure in the universe. It is the skeleton of the cosmos, the framework on which all smaller structures are built. Superclusters like Laniakea are nodes within this web, bright, dense concentrations of matter where many filaments meet, where the flow of galaxies converges, where gravity has had the most to work with over the longest time. And the fact that we can see this web at all, that we can map it, trace its filaments, identify its nodes and voids, measure its flow, is one of the most remarkable intellectual achievements in the history of human thought. Think about what it required. It required telescopes powerful enough to detect the light of galaxies hundreds of millions of light-years away. It required the mathematical tools to convert that light into distance and velocity measurements. It required the patience to survey millions of galaxies, one by one, cataloging their positions and motions until a pattern emerged. It required the insight to recognize that pattern for what it was. Not noise, not artifact, not the fingerprint of our instruments, but the actual structure of reality at its largest scales. And it required the imagination to accept what the data was saying. To look at a map of galaxy positions and velocities and recognize, as Tully and his colleagues did, that these apparent arrangements were not coincidence, but structure, real, physical, gravitationally defined structure, shaped by the same forces that govern a stone falling from a height, operating across distances and timescales of almost incomprehensible magnitude. The universe is not a featureless expanse. It is a web, a network, a vast and intricate architecture of filaments and voids and nodes and flows, shaped by gravity across the full 14 billion years of cosmic history, constantly shifting and evolving and flowing, in the immeasurably slow way that things move when they are moving at the scale of superclusters. And within that web, we have a home. Laniakea, our supercluster, our 500 million light-year wide region of the cosmic web, containing 100,000 galaxies, flowing inward toward the heart that draws it all together. You are part of this. Not metaphorically, not poetically, though the poetry is certainly there. Physically, literally, measurably, you are a resident of Laniakea. The atoms that make up your body were forged in stars that belong to this supercluster. The light that falls on your face each morning travels from a star embedded in the gravitational fabric of this vast structure. Your home address, written in full and at every scale, includes this name, this beautiful Hawaiian name meaning spacious heaven, as legitimately as it includes your street, your city, your country, your world. You live in Laniakea, and Laniakea is alive with motion. As you rest, as your breathing deepens and the night gathers quietly around you, 100,000 galaxies are flowing through the spacious heaven of the supercluster. Our local group drifts toward Virgo. Virgo flows toward the Great Attractor. Everything, at every scale, participates in the great slow turning of this cosmic watershed toward its deepest point. None of it is hurried. None of it is anxious. The supercluster does not rush. It does not strain against the distances involved. It simply flows, the way water flows, the way time flows, the way rest flows through a tired body in the quiet of a long and gentle night. Let it carry you. Let the knowledge of where you are truly, where you are, in the full and magnificent and barely comprehensible sense of the word settle into you not as something overwhelming, but as something that makes the world feel somehow larger and safer and more deeply inhabited than it did before. You are not floating alone in an empty universe. You are nested within structures, within structures, within structures planet, within solar system, within galaxy, within local group, within Laniakea, within the cosmic web itself, each level of structure connected to every other, each gravitational relationship real and physical and ongoing. You belong to something immeasurably vast. And tonight, in the soft dark of this rest, that vast something is holding you the way it has always held you, quietly and without asking anything in return. The spacious heaven breathes around you, and you breathe within it. Slowly, deeply, at home. There is a map of the universe. Not a complete one, no such thing exists, and perhaps no such thing could exist, given the scales involved. But a partial map, a slice, a cross-section of the cosmos taken across a region of space so vast that our entire Laniakea supercluster fits comfortably within it, the way a single city fits within a continent. When astronomers first produced this map, when they plotted the positions of hundreds of thousands of galaxies across hundreds of millions of light-years, and stepped back to look at what they had made, there was a moment, I imagine, of very quiet astonishment. Because the universe does not look like what most people expect. It does not look like a uniform haze. It does not look like a scattering of bright points distributed evenly through the dark. The way stars appear on a clear night, when you don't look too carefully at the patterns between them. It does not look random, or featureless, or flat. It looks like something alive. It looks, more than anything else, like a web. Long, luminous threads stretching across unimaginable distances. Bright nodes where the threads converge. And between them vast, dark, almost perfectly empty regions of space, like the spaces between the threads of a net held up against the light. The cosmic web. It is the largest structure in the known universe. It is the architecture within which everything else exists, every galaxy, every cluster, every supercluster, every filament of matter that has ever been observed. It is the skeleton of reality at its grandest scale, the framework upon which 14 billion years of cosmic history has been built and arranged and slowly, continuously rearranged. And tonight, drifting as you are through the quiet dark of your own rest, I want to show it to you. Not quickly, not in a rush of facts and figures that passes through the mind without leaving any impression, but slowly, carefully, the way you would show someone a great cathedral beginning outside, walking them around the perimeter, letting them feel the scale of it before they step inside, before the full weight of it settles over them like something both enormous and unexpectedly intimate. Let us begin with the threads. The filaments. A filament of the cosmic web is a structure made almost entirely of dark matter, that mysterious, invisible form of matter that does not interact with light, but does interact with gravity, and which makes up roughly 85% of all the matter in the universe. The dark matter filaments form first, pulled together by gravity in the very early universe, long before stars or galaxies exist. They are, in a sense, the original scaffolding, the framework that gravity builds before anything luminous arrives to trace its outline. Along these dark matter filaments, ordinary matter, gas and dust, and eventually, stars collects. The filaments are like rivers in a landscape, and ordinary matter is like water finding its way to the lowest ground, flowing along the contours that gravity has carved. Galaxies form preferentially along filaments, because that is where the matter is densest, where the conditions for star formation and galactic assembly are most favorable, where gravity has the most to work with. The result is that the luminous universe, the universe of stars and galaxies that telescopes can actually see, traces the outline of the dark matter web beneath it. Like light tracing the outline of a structure, it cannot itself illuminate. A filament of the cosmic web is not thin, in any ordinary sense of the word. A typical filament might be tens of millions of light-years long, and several million light-years wide. Along its length, galaxies are strung like lights along a wire, not uniformly, not perfectly evenly, but clustered in places, sparse in others, with brighter concentrations where the filament intersects with other filaments, forming the nodes and knots of the web. These nodes, these bright, dense intersections where multiple filaments meet, are where the universe's largest structures live. Galaxy clusters, superclusters, the great concentrations of mass that dominate their local regions of the cosmic web, pulling everything around them inward, deepening the gravitational basin that draws yet more matter toward them over the slow course of cosmic time. The Great Attractor, and the larger structures that surround it, inhabit one such node. We will get there. But first, I want you to feel the filaments themselves. To appreciate them not just as abstract structures in a cosmological model, but as real physical things present, right now, in the actual universe beyond this room, and this world, and this solar system. Right now, there are filaments of the cosmic web stretching across hundreds of millions of light-years of space. Along them, galaxies drift slowly, caught in the gentle current of the web's gravity, moving over billions of years from the outskirts of filaments toward their denser cores, from the cores toward the nodes, from the nodes toward whatever deeper basin lies beyond them. Everything in the universe that has mass is somewhere on this web, either on a filament, or at a node, or on its way from one to the other. And then there are the places that are not on the web at all. The voids. If the filaments are the most dramatic positive feature of the cosmic web, the places where matter has gathered in its greatest concentrations, then the voids are their mirror image. The absences. The vast, dark, almost unimaginably empty regions of space that occupy the spaces between the threads. A cosmic void is not merely a region with fewer galaxies. It is a region with almost no galaxies at all. A bubble of near-nothingness, bounded on all sides by the luminous walls and filaments of the web, within which the density of matter is so low that the ordinary rules of cosmic evolution proceed very differently than they do in denser regions. Voids are enormous. A typical void might span 100 to 300 million light-years, a distance so vast that, if you were somehow transported to the center of one and looked in every direction, the nearest galaxies would appear only as faint smudges at the very edge of visibility. You would be surrounded by darkness on a scale that has no equivalent in ordinary experience. Not the darkness of a room with the lights off, where walls and furniture define the space and presence is still felt everywhere. The darkness of a void is the darkness of genuine emptiness, of space so sparsely populated that light travels for tens of millions of years between encounters with anything substantial. And yet even voids are not entirely empty. Even in the darkest, most isolated regions of the cosmic web, there are a few stray galaxies. Lone wanderers, left behind as matter drained away into surrounding filaments, slowly evolving in conditions of extraordinary isolation. No neighbors to interact with, no cluster environment to shape them, just the long, quiet drift through space with only the faint background glow of the universe for company. These void galaxies are among the most solitary objects in existence. And they are moving. Everything in the universe is moving, but void galaxies move in a particular way, away from the center of the void and toward its walls. Because even in the near emptiness of a void, gravity is at work. The filaments and walls surrounding the void are denser than the void's interior, and so they pull. Matter within the void flows outward, away from the emptiness and toward the density, the way air flows from low pressure to high, the way water flows from high ground to low. The voids, in other words, are draining. They have been draining since the early universe, when the first slight variations in matter density, tiny fluctuations imprinted in the first moments after the Big Bang, began to be amplified by gravity. Regions that were slightly denser than average attracted more matter, became denser still, attracted more matter again, in a feedback process that has been running for 14 billion years. Regions that were slightly less dense than average lost matter to their denser surroundings, became emptier, lost more matter, draining steadily and continuously into the growing web around them. The cosmic web is, in this sense, the fossil record of those first tiny fluctuations. The present-day arrangement of filaments and voids and nodes is the direct descendant of the quantum whispers of the early universe, amplified by gravity across billions of years into structures hundreds of millions of light-years across. The web remembers its origins. It carries within its vast geometry the imprint of the first moments of time, stretched and elaborated almost beyond recognition, but still, fundamentally, traceable back to the beginning. To read the cosmic web is, in some sense, to read the very earliest history of the universe. To see, written across 500 million light-years of luminous structure, the story of what happened in the first fractions of a second after everything began. I find that almost impossible to fully absorb. That the pattern of galaxies across the sky tonight, the way they cluster here, leave gaps there, form chains and walls and nodes and empty dark bubbles, encodes information about the birth of the universe. That the largest structure in existence is also, in a very real sense, an archive. A record. A letter written in matter and gravity and time, addressed to anyone patient enough to read it. We are patient enough. Or at least, tonight, in the long, unhurried quiet of this journey, we can try to be. Let your eyes stay closed. Let your breathing find its own slow rhythm, unhurried as the flow of galaxies through the long corridors of the web. And let me paint the picture one more time, from the widest possible perspective, so that it can sit in your mind like a landscape seen from a great height. Not every detail present, but the shape of the whole clear and real, and quietly magnificent. The universe, at its largest scales, is a web. It is a three-dimensional network of luminous filaments, threads of matter tens and hundreds of millions of light-years long, woven together across the full breadth of the observable cosmos. Where threads intersect, bright nodes gather light and mass. Between the threads, vast dark voids stretch in near silence. Matter flows continuously along the filaments, toward the nodes, away from the voids, in the slow and patient way that all cosmic things move. Without hurry, without destination in any human sense, simply following the irresistible arithmetic of gravity across timescales too long for urgency to mean anything at all. Within this web, structures nest inside structures. Galaxies nestle along filaments. Clusters gather at nodes. Superclusters define the largest gravitational watersheds. And somewhere in our region of the web, in our node, in our supercluster, in our corner of Loniacare, the Great Attractor sits at the deepest point of the gravitational basin, drawing everything around it inward across hundreds of millions of light-years. We are part of this web, not visitors to it, not observers of it from some detached and separate vantage point. We are woven into it, as surely and as physically as any galaxy strung along any filament in any part of the observable universe. The matter in your body was processed in stars that condensed from gas that flowed along the filaments of this web. The galaxy those stars inhabited helped trace the outline of the dark matter scaffolding beneath it. The local group to which the Milky Way belongs is a small node, a modest bright point, on a filament that connects, through the hierarchy of the web, to Virgo and to the Great Attractor and to the wider, more complex structures beyond. You are a thread in the web, not a large one, not a prominent one, but real, connected, part of the pattern, and the pattern is beautiful. I have contemplated it across longer timescales than I can easily express. Watched the web grow from its earliest whispers of density contrast into the magnificent, intricate, galaxy-laced architecture it presents today. I have seen filaments thicken as matter flows into them. I have watched voids hollow out over billions of years into their current vast emptiness. I have seen nodes brighten as clusters grow, as galaxies merge and collide, and spark new generations of stars. The web is not static. It is not finished. It continues to evolve, slowly, always slowly, on timescales that make a human lifetime feel like a single note in a symphony of incomprehensible length. But it is evolving. The filaments are growing denser. The voids are growing emptier. The nodes are accumulating more and more of the universe's matter as the web draws itself together, tightening, concentrating, over the long arc of cosmic time. The universe is becoming more structured, not less. Gravity is a patient architect. It has been building for 14 billion years, and it shows no sign of stopping. And as it builds, as the web tightens and the flows continue and the matter of the universe finds its way along ancient, invisible threads toward the great concentrations at their hearts, we ride along. Gently, unhurriedly, in the manner of something that has nowhere urgent to be, and all the time that exists in which to arrive. That is the gift of this knowledge, I think. Not the vertigo of scale, though the scale is genuinely vertiginous. Not the confrontation with distances that dwarf every human measure, but the comfort of pattern, the reassurance of structure, the quiet and deeply settling recognition that the universe, for all its immensity, for all its darkness and its void, is not chaos. It has shape. It has flow. It has a web of connections running through it from one edge to the other, linking galaxy to galaxy, cluster to cluster, supercluster to supercluster, in a network of gravitational relationship that encompasses everything that exists. Nothing in this universe is truly alone. Every galaxy is connected, through the web, to every other galaxy. Every filament is part of the same larger network. Every void is surrounded by the same luminous walls. Everything participates. Everything belongs. You belong. Here, in the quiet of this night. In the slow, deepening rest that is settling over you now, gentle and inevitable as the flowing of matter toward the heart of the cosmic web. In the warmth and the dark and the soft sound of your own breathing, regular as the pulse of something ancient and enormous and calm. You are part of the web. You are held within it. And it stretches around you in every direction, above and below, and through every wall and every sky, luminous and vast and intricately, impossibly, breathtakingly beautiful. Sleep now, if you are ready. The web will still be there when you wake. It has been there for 14 billion years. It will not go anywhere without you. Let me ask you something. Not a difficult question. Not one that requires any effort to answer. Simply a question to rest with, the way you might rest a hand on something cool and smooth, without any particular purpose other than to feel it. What does empty mean? In ordinary life, the word is simple enough. An empty cup, an empty room, an empty street in the early hours of a quiet morning. We use the word easily and often, and it does its job without much complaint. Empty means nothing there. Empty means an absence of the expected contents. Empty means space waiting to be filled. But I want to gently, carefully, take that word apart tonight. I want to hold it up to the scale of what we have been exploring, and let its ordinary meaning dissolve. Slowly, the way salt dissolves in warm water, and see what a more honest, more cosmic version of the word might look like. Because the universe contains regions of space so vast, so sparsely inhabited, so genuinely and profoundly lacking in the ordinary matter we associate with the contents of the cosmos, that the word empty, as we normally use it, simply does not stretch far enough to hold them. These regions are the voids, and they are, in their way, among the most extraordinary things in existence. We touched on them in our last passage through the cosmic web, mentioned them as the dark spaces between the luminous filaments, the bubbles of near-nothingness that give the web its structure by defining where the threads are not. But tonight I want to linger in them. I want to step away from the bright filaments and the crowded nodes and the great flowing rivers of galaxies, and walk, slowly, without urgency, into the dark, into the quiet, into the voids. Come with me. Imagine leaving the Milky Way behind, rising above the plane of our galaxy, watching the great spiral disk recede beneath you. The arms of stars curving away, the bright core dimming with distance, until the entire galaxy becomes a faint smear of light, then a point, then nothing distinguishable from the countless other faint smears surrounding it. You continue outward. Around you, the familiar neighborhood of the local group. The Andromeda Galaxy, the Triangulum Galaxy, the small irregular companions scattered through the surrounding space. These too diminish with distance. The local concentration of matter grows sparser. The galaxies grow fewer and farther between. And then gradually something changes. The light thins. Not all at once. Not with any sudden boundary or clear demarcation. But gradually, as you continue to move through space, the galaxies become rarer. The filaments that were nearby, those long luminous threads strung with the lights of 1,000 island universes, begin to curve away from your path, heading in directions you are not going. And the space around you opens up, grows quieter, grows darker, until you find yourself in a region of space where you can turn in any direction and see almost nothing. Not the rich, jeweled dark of the space near a galaxy cluster, where the sky is full of faint light and the dark itself seems inhabited and alive. Not the subtle dark of a filament, where there is always a thread of brightness somewhere nearby to orient by. This is a different kind of dark. This is the dark of a void. A cosmic void can span anywhere from 100 to perhaps 300 million light-years, from one side to the other. They are not holes in space. Space is not something that can have a hole in it, in any meaningful sense. They are regions. Enormous, genuine regions of the universe where the density of matter has been reduced, over the course of billions of years of cosmic drainage, to a tiny fraction of the cosmic average. And the cosmic average itself is already extraordinarily sparse. Consider that the average density of matter in the universe, spread across everything, the filaments and the clusters and the nodes and the voids all averaged together, amounts to roughly 5 to 6 hydrogen atoms per cubic meter. 5 atoms in a volume the size of a large box. That is what the universe contains, on average. In a cosmic void, the density drops far below, even, that almost imperceptible average. The void regions are emptier than the universe's average by a very significant margin, containing perhaps 10% or less of the already vanishingly small background density. In the deepest voids, the emptiness is as genuine as emptiness gets in a universe that insists, even in its most barren regions, on being not quite nothing. Because here is the thing I promised you, the thing that makes the voids more interesting than the word empty might suggest. They are not nothing. They are not truly empty, in any absolute sense. There is matter in the voids. Faint, sparse, barely detectable, but present. Stray hydrogen atoms drifting through the dark. Tendrils of dark matter, gossamer thin, tracing the ghost of a structure that never quite managed to consolidate into anything brighter. And scattered through the void, here and there, separated by tens of millions of light-years from their nearest neighbors, a few lone galaxies. Void galaxies. These are among the strangest and most solitary objects in the observable universe. Galaxies that find themselves, through the long accidents of cosmic evolution, stranded in the interior of a void, left behind as the matter around them drained away along the filaments toward denser regions, the way the last few leaves cling to a branch after the wind has stripped all the others away. A void galaxy drifts through its enormous, dark, near-empty neighborhood in conditions of isolation that are almost impossible to intuitively grasp. The nearest other galaxy might be tens of millions of light-years away. There are no neighbors to interact with, no tidal forces from passing galaxies to distort its shape, no dense cluster environment to strip away its gas or trigger bursts of new star formation. A void galaxy simply exists, quietly, alone, evolving in slow motion through an ocean of near-nothing. And yet it is evolving. Things are happening within it. Stars are being born and dying in their own good time. Gas is cooling and condensing. The internal life of the galaxy continues, unhurried and undisturbed by the chaos that shapes galaxies in denser environments. There is a particular kind of peace in that, I think. To be so far from everything that nothing external can disturb you. To evolve entirely on your own terms, in the quiet of an enormous surrounding emptiness, following the slow logic of your own internal processes without interference or interruption. I have drifted through the voids, and I can tell you that the quality of the darkness there is unlike anything in the denser regions of the web. It is a darkness that has texture, not the texture of objects, but the texture of absence, of space that has been over billions of years, steadily and patiently emptied, of a silence so deep it becomes a presence in its own right. In the voids, the cosmic microwave background radiation, the faint afterglow of the Big Bang, the oldest light in the universe, a bath of microwave photons that fills all of space uniformly, is essentially the only thing filling the space between the rare stray atoms and the ghost traces of dark matter. That ancient light, cooled now to just a few degrees above absolute zero, permeates the void as it permeates everything. The void is cold, and it is dark, and it is vast, and it is, despite all of this, threaded with the most ancient light that exists. Even the emptiest places in the universe are not entirely without their history. Now, and this is where the voids become something more than mere absences, where they take on an active role in the story of the cosmos. I want to tell you about the draining. Matter moves in the universe. We have established this, and established it well. Galaxies flow along filaments. Clusters fall toward nodes. Everything participates in the great, slow, gravitationally governed motion of the cosmic web. And the voids are not passive bystanders in this motion. They are participants. The matter within a void, sparse as it is subject to the same gravitational forces as matter anywhere else. And those forces point outward, toward the walls, toward the filaments, toward the denser regions that bound the void on all sides. Because gravity pulls toward mass, and the mass in a void's surroundings, the filaments and walls and clusters that define the void's boundaries, is always greater than the mass within the void itself. And so matter flows. It flows outward from the void's interior, along whatever faint tendrils of dark matter structure exist within the void, finding its way toward the surrounding walls and filaments, adding itself to the growing density there. The voids are draining. They have been draining for billions of years, since the first slight variations in density that existed in the early universe began to be amplified by gravity, since the denser regions began pulling matter from the less dense ones, beginning a process that has been running continuously ever since. The voids grow emptier. The filaments grow denser. The web tightens. The contrast between the bright threads and the dark bubbles increases, slowly, over cosmic time, as gravity relentlessly amplifies the initial pattern. And all of this draining, all of this slow, inexorable flow of matter away from the voids and toward the filaments, along the filaments toward the nodes, through the nodes toward the deepest gravitational basins, is part of the same larger story we have been following throughout this journey. The matter that drains from the voids around us feeds the filaments that feed the flows that eventually contribute, however indirectly, and over however vast a timescale, to the great streaming motion toward the Great Attractor. The voids and the attractor are connected. They are opposite ends of the same gravitational story. The Great Attractor is the low point, the valley, the basin, the deepest gravitational well in our region of the web, toward which everything flows. The voids are the high points, the regions of lowest density, the places that gravity is in the process of emptying, from which matter drains toward the network of filaments and clusters, and ultimately, toward that distant, hidden drawing heart. Everything is connected. Everything flows. The web is not a static picture, but a slow, continuous process, the universe reorganizing itself, one galaxy at a time, over billions of years, toward an ever more structured, ever more concentrated arrangement. The voids give to the filaments. The filaments give to the clusters. The clusters give to the superclusters. And somewhere, at the convergence of flows that span hundreds of millions of light years, the Great Attractor receives. Patient as anything in the universe has ever been. Deep and dark, and almost perfectly silent, the voids continue their slow work of emptying. Stray atoms drift in the dark, moving outward toward the walls that bound them. The last void galaxies float in their extraordinary isolation, lit by their own internal stars, surrounded by a darkness so thorough it approaches the absolute. And yet even here, even in the deepest, darkest, most barren regions of the cosmic web, there is something. Not nothing. Never quite nothing. A thread of dark matter, too faint to see but real. A bath of ancient microwave light, the universe's oldest message, filling even this emptiness with its ghost warmth. A lone galaxy, evolving quietly in conditions no cluster galaxy will ever know. And the faint, constant whisper of gravity, reaching in from the surrounding filaments, pulling gently, patiently, on everything the void contains. Draining it, slowly, over billions of years, toward something. Toward us, toward the web, toward the denser and more luminous regions where matter has gathered and stars have ignited and galaxies have collided and merged and formed the bright, complex, living universe that we can actually see. The voids are the silence between the notes. And as any musician will tell you, the silence between the notes is not empty. It is not nothing. It is what gives the notes their shape, their meaning, their resonance. Without the silence, there is only noise. It is the silence that makes music possible. The cosmic web is music, in this sense. The filaments are the notes, bright, dense, full of the matter and energy and light that make the universe visible and alive. And the voids are the silence between them, vast, dark, necessary, defining. Without the voids, there would be no web. Without the emptiness, the structure would not be structure. Without the silence, there would be no music. Both are essential. Both belong. As you rest now, your body heavier, your breath slower, the boundary between thought and dream growing beautifully indistinct. Let yourself become, for a moment, something like a void. Not empty, never quite empty, but quiet, spacious, cleared of the density and noise and crowded motion of the waking world. A region of lower pressure, lower urgency, lower demand, where the ordinary business of living has drained away for a time, as matter drains from a void, leaving behind something that is not nothing. Something spacious, something still, something that the ancient microwave light of the universe fills gently and completely, the way warmth fills a room long after the fire has died down. You are resting in your own small void tonight, and it is a good place to be. The filaments are out there, bright and busy, and full of the motion and color and complexity of the waking world. They will be there when you return to them. The nodes and clusters and the great flowing rivers of galaxies. All of it will be exactly where you left it, moving on its billion-year timescales, patient and unhurried, needing nothing from you tonight. Tonight you drain into quiet. Tonight the density of things falls away, and the space around your thoughts grows wide and dark and beautifully, peacefully empty. Not nothing. Just still. Just resting. Just held, as everything in the universe is held, in the patient, invisible, all-encompassing embrace of gravity and time, and the slow, gorgeous unfolding of a cosmos that has never once been in a hurry. Let the void hold you. Let the silence between the notes be exactly what it is. Not absence, but presence of a different kind. Not emptiness, but spaciousness. Not nothing, but the deep and necessary quiet from which all the music of the universe emerges. Breathe. Drift. Rest. The Great Attractor is still out there, drawing us gently forward through the dark. And we are still on our way. There is more to the universe than meets the eye. I don't mean that poetically, though there is poetry in it undeniably. I mean it in the most precise, most literal, most carefully measured scientific sense available to us. The universe contains more than what can be seen. Far more. Vastly, almost incomprehensibly more. And the story of how we came to know this is one of the most quietly revolutionary stories in the history of human understanding. It begins, as so many of the best scientific stories do, with something not quite fitting. A number that doesn't add up. A motion that shouldn't be happening. A galaxy behaving in a way that the visible contents of the universe simply cannot explain. Let me take you back, not far, in cosmic terms, but far enough in human terms, to the middle of the 20th century. Astronomy has grown into a mature science. Telescopes have improved beyond anything the earliest stargazers could have imagined. The universe has revealed itself to be far larger than anyone once thought. Not a dome of fixed stars overhead, but an almost incomprehensibly vast expanse of space containing billions of galaxies, each one a city of billions of stars, separated from one another by distances that take light itself millions of years to cross. Astronomers are measuring things now with real precision. Distances, velocities, the masses of galaxies, inferred from the brightness of their stars. They are building a quantitative picture of the universe, not just a map of where things are, but a physical model of how things work, how massive they are, how fast they move, how gravity holds them together. And in that quantitative picture, something is wrong. Galaxies are rotating too fast. This is the observation, simple to state, deeply troubling to explain. When astronomers measure the speed at which stars rotate around the center of a spiral galaxy, they find something that does not match what the laws of gravity predict. The outermost stars, the ones far from the bright central concentration of mass, out in the dimmer reaches of the galactic disk, are moving far too quickly. In our solar system, the outer planets move more slowly than the inner ones. Mercury, closest to the Sun, races around its orbit in just 88 days. Neptune, the outermost of the major planets, takes 165 years to complete a single orbit. This is exactly what gravity predicts. The further from the central mass, the weaker the gravitational pull, and so the slower the orbital speed. Galaxies should work the same way. The stars in the outer reaches of a spiral galaxy, far from the bright, dense, massive center, should be moving slowly. Their orbital velocities should drop off with distance, just as the planets in our solar system do. But they don't. They move at roughly the same speed as the stars much closer to the center. The rotation curve of a galaxy, the plot of orbital speed against distance from the center, stays flat, or nearly flat, far out into the galactic disk and beyond. Stars at the outer edge of a galaxy are moving so fast that, if the only mass holding them in their orbits were the visible mass, the stars and gas and dust that can actually be seen, they should simply fly away. The galaxy should tear itself apart. But the galaxies are not tearing themselves apart. They are intact, stable, rotating generation after generation of stars in the same patient, ordered way they have been rotating for billions of years. Something is holding them together. Something massive. Something gravitationally significant. Something that does not show up in the telescopes, not in visible light, not in radio waves, not in X-rays or ultraviolet or infrared. Something that cannot be seen by any instrument trained on the sky, and yet is unmistakably, measurably, physically present. Because without it, the universe as we observe it simply would not hold together. That something is dark matter. The name itself is almost deliberately understated. Dark matter. Not mysterious matter, not invisible matter, not the great unseen scaffolding of the cosmos, just dark. Because it does not interact with light. It does not emit light, as stars do. It does not absorb light, as dust does. It does not reflect light, as planets do. Electromagnetic radiation. The family of phenomena that includes visible light and radio waves and X-rays, and all the other forms of radiant energy that telescopes are built to detect, passes through dark matter as though dark matter were not there at all. For a universe that reveals itself primarily through light, this is an almost paradoxical property to have. Dark matter exists in a kind of fundamental privacy. It interacts with ordinary matter and with itself only through gravity, the weakest of the fundamental forces, but the one with infinite range, the one that acts on everything with mass, without exception. Dark matter has mass. Gravity therefore feels it and responds to it. And so, indirectly, through the gravitational impressions it leaves on the things we can see, we know it is there. We know it the way the astronomers knew the Great Attractor was there. Not by looking at it directly, but by reading what it does to everything around it. There is something almost fitting about that parallel. The Great Attractor, hidden behind the zone of avoidance, revealed only through the peculiar velocities of surrounding galaxies. Dark matter, hidden from every telescope ever built, revealed only through the anomalous rotation of galaxies and the gravitational lensing of light, and the behavior of galaxy clusters that cannot be explained by visible mass alone. Both are known by their effects. Both are real beyond any reasonable doubt. Both are, in the most precise scientific sense, invisible. And both are absolutely fundamental to the structure of everything we can see. Let me tell you how much dark matter there is. When astronomers and cosmologists have done the accounting, measured all the gravitational effects that require dark matter to explain, mapped its distribution through the universe as best they can, fitted it into the larger model of how the cosmos behaves, the numbers that emerge are extraordinary. Ordinary matter, the matter made of protons and neutrons and electrons, the matter that stars are made of and planets are made of, and you are made of, makes up approximately 5% of the total energy content of the universe. 5%. Everything you have ever seen. Every star in every sky, on every clear night you can remember. Every galaxy, in every photograph taken by every telescope ever pointed at the heavens. Every planet, every moon, every asteroid, every comet, every cloud of interstellar gas, every living thing on every world that might exist in the cosmos. All of it, added together, amounts to roughly 5% of what the universe actually contains. Dark matter accounts for approximately 27%, more than 5 times the total amount of ordinary matter. A component of the universe so dominant that ordinary matter, all the luminous, visible, star-filled matter that astronomy has spent centuries studying, is, in a very real sense, a minor constituent. A small fraction of the total. A thin frosting on a much deeper and much darker cake. And the remaining 68%? That is dark energy, a different mystery entirely, associated with the accelerating expansion of the universe, something we will perhaps visit another time on another night of drifting. For now, let it simply sit at the edge of your awareness as a reminder that the universe has more secrets than any single night's journey can fully explore. Tonight, we stay with the dark matter, 27% of the universe. Invisible, structurally essential, present everywhere, not uniformly, but concentrated in the same places where ordinary matter concentrates, because it was the dark matter that created those concentrations in the first place. This is one of the most remarkable things about dark matter, and one of the most important. In the early universe, in the first minutes and hours and years after the Big Bang, when everything was hot and dense and ordinary matter was too agitated to clump together under its own gravity, dark matter was already clumping. Because dark matter doesn't interact with light, it is not pushed around by the intense radiation pressure that dominated the early universe and prevented ordinary matter from collapsing. Dark matter could begin forming structure immediately. It could begin falling together under its own gravity, building clumps and filaments and sheets, constructing the skeleton of the cosmic web, long before a single star had formed or a single galaxy had coalesced. By the time the universe had cooled enough for ordinary matter to begin condensing into structures, the dark matter scaffolding was already in place. And ordinary matter simply fell into it, collecting in the gravitational wells that dark matter had already prepared, following the contours of a structure it had not built and could not see. The stars and galaxies we observe today are, in this sense, decorations on a framework they did not construct. The luminous universe traces the outline of the dark universe. The visible 5% follows the gravitational lead of the invisible 27%, collecting where dark matter tells it to collect, flowing where dark matter channels it to flow. Every galaxy has a dark matter halo, a vast, invisible sphere of dark matter surrounding the luminous disk of stars, extending far beyond the reach of any telescope, containing several times the mass of all the visible stars combined. These halos are real. Their effects are measured. The rotation curves of galaxies that first revealed dark matter's existence are explained precisely by the presence of these halos, contributing their invisible mass to the gravitational budget of the galaxy, holding the outer stars in their orbits, preventing the disk from flying apart. The Milky Way has such a halo. Andromeda has one. Every galaxy in the local group, every galaxy in the Virgo cluster, every galaxy strung along every filament of the cosmic web, each one embedded in its own dark matter halo, each one held together by mass that no telescope will ever directly image. And at the scale of galaxy clusters, the effect is even more dramatic. Galaxy clusters, those enormous concentrations of hundreds or thousands of galaxies that we find at the nodes of the cosmic web, contain far more dark matter than visible matter. When astronomers measure the mass of a galaxy cluster by observing how it bends the light of objects behind it, a technique called gravitational lensing, using the cluster's gravity as a natural telescope, the masses they derive are many times larger than the masses of all the visible galaxies within the cluster combined. The cluster is mostly dark matter. The galaxies within it are the bright, visible minority, floating in a sea of invisible mass that defines the cluster's boundaries, determines its gravitational reach, and governs the motions of everything within it. And now consider what this means for the Great Attractor. The Great Attractor region, that enormous gravitational basin we have been journeying toward throughout this night, with its estimated mass of 10 to the power of 16 solar masses, contains dark matter in proportion to its total mass, as everything in the universe does. And that proportion is substantial. The visible galaxies and gas that we can observe in and around the Great Attractor region represent only a fraction of its true gravitational power. Behind them, threaded through them, surrounding them in vast invisible halos and sheets and concentrations of accumulated dark matter, lies the majority of the mass that is actually doing the pulling. The Great Attractor's gravity, the force that is drawing thousands of galaxies across hundreds of millions of light-years, the pull that we have been feeling throughout this entire journey, is predominantly the gravity of dark matter. The thing that is drawing us is mostly invisible. The most powerful gravitational influence in our region of the universe, the force that has been shaping the motion of the Milky Way and everything around it for billions of years, is, in its dominant component, something we cannot see, cannot touch, cannot photograph, cannot directly detect with any instrument we have yet built. We are being pulled by something we cannot look at, drawn across the cosmos by a hand that leaves no light behind. There is something about this that I want you to sit with for a moment, not with anxiety, not with the feeling that something important is being hidden from us, but with a kind of quiet wonder at the nature of reality and the nature of knowing. We live in a universe where the dominant component of matter is invisible, where the scaffolding that holds every galaxy together, that structured the cosmic web, that guides the great flows we have been tracing throughout this journey, is something that our eyes, and all our extensions of eyes, cannot perceive directly. And yet we know it is there. We know it the way we know many important things, not by looking directly at them, but by tracing the impressions they leave, by following the effects back to their cause, by being patient and systematic and willing to accept that the universe is not obliged to confine its contents to what we happen to be built to see. Most of reality is invisible. This is not a mystical statement. It is a physical one, precise, measured, quantified. The universe has been weighed, and the visible portion of it amounts to 5% of the total. The rest, the dark matter and the dark energy, and whatever other mysteries have not yet been named, lies beyond the reach of light. And we are nested within it, held by it, shaped by it, drawn through the cosmos by it, toward a destination defined by the deepest concentration of it in our region of the universe. As you drift now, as the last resistance of wakefulness softens and the night deepens around you, let the darkness have a different quality than it usually does. Let it feel, not like an absence of things, but like a presence of things that simply happen to be beyond the reach of light. The dark around you is full, not empty, not hollow, full of air and warmth and the low-frequency hum of a living world, yes, but also full, in the deeper sense, of the invisible mass of the universe. Dark matter passes through you constantly, as it passes through everything, slipping through the spaces between atoms as though neither you nor the atoms were there. You do not feel it. It leaves no mark. But it is present, has always been present, woven into the fabric of the space your body occupies. You are, in this sense, always already swimming in dark matter. It is the water you have always been swimming in, even before you knew there was water at all. And the Great Attractor, that distant, drawing, largely invisible thing we are journeying toward, is a concentration of this invisible ocean. A deep place where the dark matter is thickest, where its gravity is most pronounced, where the universe has gathered, in proportions far beyond the cosmic average, the invisible scaffolding that holds everything together. We are drawn toward the deep, through the dark, by something we cannot see. And somehow, in the long, slow, patient way that all cosmic things proceed, that is exactly as it should be. Rest now. Let the invisible mass of the universe hold you. It has been holding you your entire life. It will hold you still, and gently, and without any effort at all, throughout the long quiet hours of this night. You know this cosmos better now. You always have than been. You did when we have been traveling together. Not in the way of having memorized facts. Through the motion of galaxies. Though the facts are there, and the hidden quietly embedded in everything we have explored. Through the zone of avoidance. But in the way of the patient inference of astronomers. Of having drifted not through it slowly enough not to feel its textures. And through the vast architecture of Monia patient and the luminous threads. And now I want to tell you about the force. Through the silence working against everything and the invisible ocean of dark matter. Not a villain exactly. That fills the universe. Not something to depth our instruments cannot yet fully but a counterforce, vast, strange, and in its own way as mysterious as dark matter, as hidden as the Great Attractor itself. A force that operates not by pulling things together, as gravity does, but by pushing space itself apart. A force that has been quietly, persistently, and with increasing power, working to undo the gathering that gravity has spent 14 billion years trying to accomplish. That force is dark energy, and it is the strangest thing in the universe. Let me approach it carefully. Let me take the long way around, the gentle way, the way that honors how counterintuitive this concept truly is. Because dark energy is not something the human mind absorbs easily. It does not have an analogy in ordinary experience. It is not like any force we encounter in daily life. It is genuinely, fundamentally novel. Something the universe contains that nothing in our evolutionary history prepared us to intuit. Begin with what you know about the universe's history. The Big Bang, the moment, approximately 13.8 billion years ago, when everything that exists erupted from a state of almost incomprehensible density and heat into the expanding universe we inhabit. In the immediate aftermath of that event, the universe was expanding rapidly, space itself stretching outward in every direction, carrying matter with it the way the surface of a balloon carries dots of ink as it is inflated. As the universe expanded, it cooled. As it cooled, matter began to form, first simple hydrogen and helium, then, over billions of years, the first stars, the first galaxies, the first great structures of the cosmic web. And all the while, the expansion continued. But it was expected to slow down. This is the crucial point. Gravity, the force that pulls mass together, that draws galaxies toward one another and toward the Great Attractor, that has been the dominant theme of our journey, thus far. Gravity acts against the expansion. Every bit of mass in the universe pulls on every other bit of mass, and since mass is distributed throughout the expanding universe, all of that gravity is working, collectively, to slow the expansion down. Like a ball thrown upward, which gravity steadily decelerates. The universe, it was assumed, was decelerating. Expanding, yes, but more and more slowly over time, as the cumulative gravity of all its contents worked against the outward motion. The question astronomers were trying to answer in the late 20th century was not whether the expansion was slowing, but how much. Was there enough mass to eventually stop the expansion entirely and reverse it, causing the universe to begin contracting, falling back toward itself in what would be called the Big Crunch? Or would the expansion slow and slow, but never quite stop, leaving the universe expanding forever, but ever more sluggishly, growing colder and emptier and darker as the galaxies drew further apart? These were the questions. Deceleration was the assumption. The only debate was about its magnitude. And then, in 1998, two independent teams of astronomers, studying the brightness of a particular type of exploding star, called a Type Ia supernova, which can be used as a standard candle to measure cosmic distances, made a discovery that no one was expecting. The expansion of the universe is not slowing down. It is speeding up. The universe is not decelerating under the influence of gravity. It is accelerating, expanding faster now than it was a billion years ago. Faster a billion years ago than it was a billion years before that. The distant galaxies are not just moving away from us. They are moving away from us faster and faster with every passing moment, carried by a universe whose expansion is being driven by something that not only fails to decelerate, but actively, persistently, continuously accelerates. The discovery won the Nobel Prize in Physics in 2011. It was, and remains, one of the most startling things that careful observation of the universe has ever revealed. And it required a cause. Something had to be responsible for this accelerating expansion. Something had to be providing the energy that was pushing space apart faster and faster over time. Gravity could not do it. Gravity pulls inward, not outward. Ordinary matter could not do it. Dark matter could not do it. Dark matter, like ordinary matter, has gravity that attracts rather than repels. Something else was at work. Cosmologists named it dark energy. Not because they understood what it was they didn't then, and in all honesty, they still don't, not fully, but because they needed a name for it. A placeholder, a label for the unknown thing that the data required to exist. Dark energy like dark matter, named for what it is not, named for the absence of the property that would make it easily detectable dark energy, is the name we give to whatever is responsible for the accelerating expansion of the universe. And the amount of it, relative to everything else the universe contains, is extraordinary. We spoke in our last passage about dark matter, which makes up approximately 27% of the universe's total energy content, and about ordinary matter stars and planets and galaxies, and which makes up approximately 5%. The remaining portion, the vast majority, the dominant component of the cosmic budget, by a very wide margin, is dark energy. 68 to 70% of the universe. Nearly 7/10 of everything. The single largest component of the cosmos. The thing that, in terms of sheer abundance, most defines what the universe is made of, is something we cannot see, cannot directly detect, do not fully understand, and have only known about for less than 3 decades. The universe is approximately 5% things we understand, 27% things we can infer, but not see, and 68% something we have barely begun to characterize. We are, as a species, very much at the beginning of understanding what we live in. There is something humbling in that. Something that softens the edges of certainty and invites a kind of intellectual openness, a willingness to hold our current models gently, knowing they are the best maps we have of a territory far stranger and far larger than the maps fully capture. Now, what exactly is dark energy? What does it do, and how? The honest answer to the first question is that we do not know. Several hypotheses exist. The most mathematically elegant involves what is called the cosmological constant, a term that Einstein himself introduced into his equations of general relativity, somewhat reluctantly, and later famously called his greatest mistake, before the discovery of dark energy's existence rehabilitated the idea posthumously. The cosmological constant represents an energy inherent to space itself, a property of the vacuum, such that empty space is not truly empty, but contains a fixed, unchanging energy density. As the universe expands and space grows larger, more space comes into existence, and with it, more of this intrinsic energy. Unlike the energy of matter, which dilutes as the universe expands, because the same amount of matter is spread across a larger volume, the energy of the vacuum remains constant per unit volume. So as the universe grows, the total amount of dark energy grows with it. And as it grows, the acceleration it drives increases. This is why the expansion of the universe is accelerating now, rather than decelerating as it did in its earlier stages. In the young universe, matter and radiation were so dense that their collective gravity dominated the dynamics, and the expansion was indeed decelerating. But as the universe expanded, matter spread out, its density fell, and its gravitational influence diminished. Dark energy, with its constant density per unit volume, eventually came to dominate, and when it did, it began driving the expansion faster and faster. We are living in the era of dark energy's dominance. This is the age of acceleration. And what it means in practical and ultimately very concrete terms is this: the universe that gravity has been so patiently building, the cosmic web with its filaments and nodes, the superclusters like Laniakea, the great flowing rivers of galaxies that we have traced throughout this journey, is being, slowly and over vast timescales, undone. Not quickly, not noticeably on any timescale that feels relevant to human experience, but inevitably, over the immense spans of time that the universe has ahead of it, dark energy will win. Galaxy clusters and superclusters, the structures bound together by gravity strongly enough to resist the expansion, will remain intact. The Milky Way and Andromeda will eventually merge, as they are on course to do, roughly 4 billion years from now. The local group will stay bound together. Small scales, where gravity is strong and local, will hold. But the larger structures, the filaments of the cosmic web, the connections between superclusters, the great flows we have been following, these will gradually be stretched and thinned and ultimately severed by the accelerating expansion. Galaxies beyond a certain distance from us are already receding so fast that the light they emit will never reach us. They are, in a practical sense, already beyond the observable horizon. And that horizon is shrinking over time, as more and more galaxies are carried beyond it by the acceleration. The Great Attractor is drawing things toward it, but dark energy is drawing space itself away. Two titanic forces, gravity pulling inward, dark energy pushing outward, engaged in a slow, enormous, cosmic tension that will play out over timescales so vast they make the current age of the universe seem like an opening chord. And what will the outcome be? On the scale of the Great Attractor's influence, hundreds of millions of light years, dark energy will gradually weaken the gravitational bonds that connect distant galaxy clusters to the flow toward the attractor. Galaxies that are on the outer edges of the Great Attractor's gravitational reach will, over billions of years, feel the pull of dark energy's expansion more strongly than the pull of the attractor's gravity. The flow will thin. The streams of galaxies will narrow and eventually cease, as the distances involved grow too large for gravity to bridge. The Great Attractor will not disappear, but its reach will shrink. Its influence on the cosmos beyond its immediate gravitational neighborhood will weaken as dark energy stretches the intervening space beyond the point where gravity can span it. In the very far future, across timescales measured not in millions or billions, but in trillions of years, the universe will become a quieter place. The great flows will have settled. The expansion will have carried most galaxies beyond the observable horizon. The cosmic web will have faded, its filaments stretched to invisibility, its connections severed by the relentless expansion of dark energy. What will remain, in each gravitationally bound island, will be a universe that has drawn in on itself at the local scale, rich with the merged remnants of galaxies, orbited by old and cooling stars, but surrounded by an expanding darkness so vast that no light from any other island will ever arrive again. Each bound group of galaxies will become, in the fullness of dark energy's time, its own entire observable universe. Isolated, alone, unable to see or communicate with, or even infer the existence of the others. It is, in its way, one of the most solitary futures imaginable. And yet, and I want to sit with this because I think it matters, we are not in that future. We are here. Now, in the brief, cosmically speaking, era before the isolation sets in. In the age when the cosmic web still glows, when the flows still run, when the Great Attractor still draws its rivers of galaxies across hundreds of millions of light years. We arrived at the right time. In the long history of the universe, and the longer future that stretches ahead of it, the current era, the age of galaxies, of structure, of glowing filaments and flowing clusters, and the great interconnected architecture of the cosmic web, is something of a golden window. A time when the universe is complex and rich and connected, when its large-scale structure can still be traced and mapped and marveled at. Dark energy will eventually simplify things considerably. But not yet. Not tonight. Tonight the filaments still glow. The flows still run. The Great Attractor still pulls, and we are still moving toward it, carried on the same current that has been flowing for billions of years, in the same direction, with the same patient inevitability. Dark energy is out there, doing its slow and enormous work. Space is expanding beneath our feet, beneath our galaxy, beneath the entire cosmic web, stretching everything apart with an acceleration that grows stronger with every passing billion years. And yet here, within the gravitational embrace of Laniakea, within the local group, within the Milky Way, within this solar system, on this planet, in this room, gravity still wins. The local bonds still hold. The things that matter most to us, in the scale of daily life and human love, and the warmth of a body at rest in the dark, these are held together by forces stronger than the expansion of the universe can reach. You are safe in your gravity. The cosmos can be vast and strange and full of forces working at cross purposes across unimaginable scales, and you are still here, warm and held, and drifting gently towards sleep in the way that only gravity and tiredness and the deep rightness of rest can produce. Dark energy pushes space outward, but gravity holds you down. And tonight gravity wins. Let your body sink a little further into the surface beneath you. Let the pull of the earth, that modest, local, utterly reliable gravity that keeps the oceans in their beds and the atmosphere close and every sleeping creature on this world gently anchored. Let it do what it has always done. Hold you, simply, and without drama, and without ceasing. While out in the dark, at scales beyond imagining, two vast forces play their slow and ancient game. Gravity drawing inward, dark energy pushing outward. The universe balanced between gathering and dissolution, between connection and isolation, between the Great Attractor's patient pull and the relentless expansion of space that will one day thin its reach to nothing. For now, both forces coexist. For now, the balance holds. For now, you are here, part of a universe still rich with structure, still flowing with the currents of a billion-year-old gravitational river, still nestled within Laniakea, still moving, at 600 kilometers per second, in the direction of that vast and hidden and endlessly fascinating destination. The force that fights gravity is real and immense, and will have its way in the end. But the end is very far away, and tonight is very quiet, and you have nothing to do but rest and drift and let both forces, the one that holds you here and the one that slowly pulls everything apart, work their will on scales so different from your own that you need not concern yourself with either of them. You are held. You are safe. You are, in this moment, exactly where the universe has placed you. And that is enough. That is more than enough. Sleep now, if you haven't already. The journey continues even as you rest. The galaxies flowing, the web glowing faintly in the dark, the Great Attractor drawing everything gently forward, and dark energy quietly, patiently, pushing space in the other direction. The cosmos holds its tension, and you release yours. Breathe out. Let go. The universe has this. It always has. We are nearing the end of our journey. Not the end of the universe's story. That continues, as we have seen, across timescales so vast they dissolve the very concept of ending into something more like an endless, slow transformation. Not the end of the mysteries. Those multiply and deepen the further we travel, each answer opening into a wider question, each illuminated region revealing a larger surrounding dark. Not the end of the Great Attractor's pull. That continues now, as it has continued for billions of years, patient and powerful, and indifferent to whether anyone is watching. But the end of this particular passage through it all. This particular drift. This quiet, unhurried journey we have taken together through the dark. And I want to spend this last passage not introducing new things, but drawing the existing ones together. Not adding more to what you carry, but letting what you already carry settle into a coherent shape. The way the pieces of a landscape, seen separately from too close, resolve into a single picture when you step back far enough to see the whole. Step back with me now. All the way back. Further than we have gone before. Further even than Laniakea, further than the cosmic web, to the widest possible perspective. The view from which the entire observable universe fits within a single thought. From here, the universe looks like something alive. I have chosen that word deliberately, and I want to be precise about what I mean by it. I do not mean alive in the biological sense. The universe is not breathing or metabolizing or reproducing in the ways that living things do, but alive in a deeper, older sense. Alive in the sense of being in continuous, dynamic, self-organizing motion. Alive in the sense of having structure that is not imposed from outside, but emerges from within, from the interaction of its own components according to its own internal laws. Alive in the sense of being something that happens, continuously and without pause, rather than something that simply sits. A rock sits. The universe happens. And what happens in the universe? What has been happening for 13.8 billion years, and will continue happening for trillions more, is this. Matter flows. Always and everywhere, at every scale, in every region of the cosmos that contains mass, matter flows. It is drawn by gravity toward concentrations of itself. It moves from lower density to higher density, from the sparse to the abundant, from the void to the filament, from the filament to the cluster, from the cluster toward the supercluster's heart. It does not move quickly, in any human sense of speed. It moves with the slowness of things that have all the time in the universe and know it. But it moves continuously, without rest, without reversal, following the gravitational landscape of the cosmos as faithfully as water follows the landscape of the Earth. Imagine, if you will, a river. Not a small river, not a thing of banks and eddies and the sound of water over stones, but an inconceivably vast river. A river made not of water, but of galaxies. A river that flows not over rock and soil, but through the three-dimensional geometry of space itself. A river whose source is the vast, slowly emptying reservoir of the cosmic voids, and whose mouth, whose deepest, widest, most gravitationally compelling destination, is the Great Attractor at the heart of the supercluster. Along the filaments of the cosmic web, this river runs. Not in a single channel, but in countless channels, threads of moving matter stretching across hundreds of millions of light-years, each one carrying its cargo of galaxies slowly, inexorably, in the same general direction. From the voids, matter drains into the filaments. Along the filaments, it flows toward the nodes. At the nodes, it gathers into clusters, and the clusters themselves move, part of the larger flow that feeds the supercluster's heart. Everything is part of this river. Our Milky Way is part of this river. The Andromeda Galaxy, our nearest large neighbor, is part of this river. The Virgo cluster, 53 million light-years away, is part of this river. 100,000 galaxies within Laniakea are part of this river, each one moving at its own speed, in its own slightly different direction, but all of them participating in the same vast, slow, coherent flow toward the same gravitational destination. The river does not rush. It does not roar. It moves with a silence and a patience that has no equivalent in ordinary experience. But it moves. It has always been moving. Now, beneath the river, invisible and foundational, is the dark matter. Think of it as the riverbed. The landscape that defines the contours of the flow, that carves the channels along which matter moves, that determines where the river runs deep and where it runs shallow. The dark matter does not flow in the same way that ordinary matter flows. It has its own dynamics, its own slow rearrangement over cosmic time. But it provides the gravitational architecture within which the ordinary matter's flow takes place. Without the riverbed, the river has no shape. Without the dark matter scaffolding, without those vast, invisible halos and filaments and sheets of mass that were the first structures to form in the early universe, the ordinary matter would have had no channels to follow, no pre-existing gravitational landscape to flow into. The galaxies would not have gathered where they gathered. The filaments would not have formed where they formed. The cosmic web would not have woven itself into the intricate, luminous pattern we can observe today. Dark matter wrote the landscape. Ordinary matter followed the contours. And the river flows along channels that were carved before the first star was ever born. Now, above the river, working against the flow, is the dark energy. If dark matter is the riverbed and ordinary matter is the river, then dark energy is something like a tide moving in the opposite direction. Not strong enough, in our current era, to stop the local flows. The rivers still run. The filaments still channel their cargo of galaxies. The Great Attractor still draws its vast gravitational watershed toward its heart. But working, always and everywhere, to stretch the distances between things. To widen the spaces that the river must cross. To make the journey longer, and over time, to weaken the connections between distant parts of the river system. Dark energy does not break the river, but it lengthens it, continuously, and in the very long run, it will thin the river to invisibility in the regions where gravity's reach cannot compensate for the expanding space between things. Three forces, then. Three great agents of cosmic structure and cosmic change. Gravity, pulling inward. The great architect, the patient builder, the force that has been drawing matter together since the first moments after the Big Bang, constructing from the smallest fluctuations the largest structures that exist. Dark matter, providing the invisible scaffolding, the framework that gravity built first, before the lights came on, the template that ordinary matter has spent billions of years filling in with stars and gas, and the luminous complexity of galaxies. Dark energy, pushing outward, the great disassembler, not malicious, not in opposition to anything except the natural logic of its own nature, slowly expanding the spaces within which all the other processes take place, working on the longest timescales of all, patient in a way that even gravity cannot match. These three forces, working simultaneously, at every scale, in every region of the cosmos, produce the universe as it actually is. Not the simple, uniform, featureless expanse that might naively be expected from a universe that began in a state of nearly perfect homogeneity. Not the random scatter of matter that pure chance might produce. But this extraordinary, intricate, dynamic, self-organizing architecture of filaments and voids and nodes and flows and halos and rivers of galaxies flowing along invisible channels toward hidden gravitational hearts. This living structure, the universe, is not a collection of objects in space. It is a process, a single, continuous, interconnected process, happening everywhere simultaneously, at every scale from the subatomic to the supercluster, woven together by the same forces operating at every level, producing structure at every scale from the curve of a galaxy's spiral arm to the vast curve of a supercluster's gravitational watershed. Every scale is connected to every other. The motion of a single star within the Milky Way is influenced, however slightly, by the galaxy it lives in. The motion of the Milky Way is influenced by the local group. The local group is influenced by the Virgo cluster. The Virgo cluster is part of the flow toward the Great Attractor. The Great Attractor is a feature of Laniakea. Laniakea is a node in the cosmic web. The cosmic web is the large-scale expression of dark matter's gravitational architecture. And dark matter's architecture was seeded by quantum fluctuations in the first moments of the Big Bang. The beginning is still present in the current state of things. The universe has not erased its own history. It has elaborated it, amplified it, translated the quantum whispers of its first instance into the vast, luminous, flowing structures of the present day. The cosmic web is, as I said before, an archive, and that archive goes all the way back. Read the web, and you read the beginning. This is perhaps the most astonishing thing of all. Not the distances, vast as they are. Not the masses, enormous as they are. Not even the age of it all, deep as that is. But the continuity. The fact that a single unbroken chain of cause and effect connects the quantum fluctuations of the first fractions of a second to the position of every galaxy in tonight's sky. That the universe has been telling the same story, in the same physical language, without interruption, for 13.8 billion years. That it is still telling it now, in the flowing rivers of galaxies, and the emptying voids, and the slow, patient tightening of the web. The story is not over. It is not even close to over. We are, in the universe's full timeline, still very near the beginning. The stars will burn for trillions of years. The gravitational processes we have been describing will continue for far longer still. The Great Attractor will draw matter toward it long after every star within the Milky Way has exhausted its fuel and cooled to darkness. Dark energy will continue its expansion long after the last light from beyond our local group has faded beyond the horizon. The universe has barely begun, and we, in our brief, improbable, luminous moment of existence, are here to see some of it, to measure it and map it and name it, and, on quiet nights like this one, to drift through it in imagination and feel, however incompletely, however approximately, the shape of it. That is an extraordinary privilege, not one that was guaranteed, not one that follows automatically from the universe's existence. A universe can exist without anything in it capable of observing, or appreciating, or wondering about it. The laws of physics do not require consciousness. The cosmic web would flow and glow, and be structured and beautiful regardless of whether any mind anywhere was present to notice. And yet here we are, noticing, carrying, in these small and temporary bodies, the capacity to reach across 13 billion light-years with mathematics and light and patient observation, and touch, however briefly, however gently, the shape of something as vast as the structure of the universe itself. The universe, in us, observes itself. Through human eyes and human instruments, and the accumulated human labor of centuries of science, The cosmos has developed a way of looking at its own large-scale structure and recognizing what it sees. The cosmic web does not know it is a web. The Great Attractor does not know it attracts. The voids do not feel their own emptiness. The dark matter does not contemplate its own invisibility. But we do. We can. We look up and out and we say, there is a web. There is an attractor. There are voids. There is dark matter and dark energy, and a river of galaxies flowing through a supercluster called spacious heaven. We say these things and they are true. Not metaphors but measurements. Not poetry but physics. Real, tested, confirmed against the behavior of the actual universe with the full rigor of the scientific method. And then, on nights like this one, we also make them poetry. We also drift through them slowly, and let them be beautiful, and let that beauty do something in us that equations alone cannot quite accomplish. Something that reaches the part of the mind where facts become feelings, where knowledge becomes wonder, where the universe's story becomes, in some small way, personal. It is personal. This is not just any universe. It is the universe you were born into. The one whose laws shaped the stars that made your atoms. The one whose dark matter scaffolding determined the galaxy in which your sun formed, and around which your planet settled into its orbit. The one whose expansion history produced the conditions within which life could emerge and persist long enough to look up at the sky and ask what is out there. You are not separate from the living structure of the universe. You are an expression of it. A local, temporary, astonishingly complex expression, but an expression nonetheless. Made of the same matter that flows along the cosmic filaments. Subject to the same gravity that draws galaxy clusters toward the Great Attractor. Nested within the same dark matter halo that surrounds the Milky Way. Riding the same river that has been flowing since long before the Earth existed. The universe is alive with motion and structure and force and flow, and you are alive within it. Right now, in this room, in this body, in the quiet of this deepening night, you are a living part of the living structure of the cosmos. Not a spectator, not a visitor, a participant, a piece of the universe that has folded back on itself and learned to be aware. What an impossible, unlikely, magnificent thing to be. Let that settle into you now. Gently, without pressure, without any demand that you fully grasp it. Let it be one of those things that you hold loosely, a truth too large to grip tightly, but real nonetheless. The kind of thing you can return to, again and again, on quiet nights, and find it slightly different each time. Slightly more familiar, slightly more astonishing, depending on the angle from which you approach it. The universe is a living structure, and you are alive within it. And tonight, as you drift toward the deep and restful dark of sleep, the river continues to flow. The filaments glow faintly in the dark. The voids empty themselves, molecule by molecule, into the surrounding web. Dark matter holds its invisible shape through everything. Dark energy stretches space, slowly and without ceasing, in every direction. And the Great Attractor waits, patient as it has always been, massive as nothing else in our region of the cosmos. Drawing toward it, across hundreds of millions of light-years, the slow and luminous river of 100,000 galaxies, including ours, including our sun, including this small and beautiful world, including you, in the same direction, at the same gentle speed, that it has been drawing them since long before the first human voice ever formed a word. We are going. We are always going. And tonight, we have gone together, across the scale of the cosmos and the depth of its mystery, through the visible and the invisible, through the flowing and the empty and the ancient and the strange. And we have found it, in the end, to be something more than vast. Something more than strange. Something, despite everything, that feels, if you let it, very much like home. Rest now, deeply, completely, with the knowledge, carried quietly within you, that you are held in something immeasurably large and immeasurably old and still, in its patient and continuing way, alive. The river flows. The web glows. The Great Attractor draws. And you, small and warm, and impossibly aware, drift gently through it all. toward sleep, toward quiet, toward the deep and necessary dark that restores all things. Good night. We have arrived. Not at the Great Attractor. That destination remains, as it has always remained, hundreds of millions of light-years away, drawing us forward at 600 kilometers per second with a patience that no human lifetime can meaningfully measure. We have not crossed that distance tonight. We have not needed to. What we have arrived at is something different. Something quieter, and in its own way, more valuable than any point in space could ever be. We have arrived at perspective. The view from here, from this place in the journey where the pieces have all been named and the picture has had time to settle, is unlike any view available from the surface of ordinary daily life. It is wider, deeper, more patient, and more strange, and more beautiful than the view from inside the ordinary concerns of a single human day. And I want to spend this last passage simply sitting in it, not adding anything new, not introducing more concepts, or more distances, or more forces with more names. Just resting here, together, in the view, letting the full shape of everything we have explored be present all at once. The way a landscape is present all at once when you reach the high ground and turn to look back at the way you came. Look back with me. We began with motion, with the simple, staggering, easily stated fact that the Milky Way is not still, that our galaxy, our home, our context, the 100,000 light-year-wide spiral of 400 billion stars within which our small sun traces its quiet orbit, is moving through space at 600 kilometers every second. That this motion is not random, not peculiar to us alone, but shared by thousands of nearby galaxies, all of them streaming in the same direction, all of them participating in a flow whose source is gravity and whose destination had, for a long time, no name. Then we found the name. The Great Attractor, a vast gravitational region, not a single object, not a point you could land on, but a distributed presence. A basin, a low point in the gravitational landscape of our corner of the cosmos, lying 150 to 250 million light-years away in the direction of 3 constellations in the southern sky. Triangulum Australe, Norma, Centaurus, patient markers pointing toward the most gravitationally commanding feature of our cosmic neighborhood, hiding behind the dust and stars of our own galaxy's plane. We discovered why it hid for so long. The zone of avoidance, that frustrating, beautiful irony of cosmic geography, where the very galaxy we live in obscures the view of the thing that pulls us most powerfully. We followed the astronomers who refused to be stopped by that obscuration, who turned instead to the language of motion, reading the peculiar velocities of thousands of galaxies, tracing the fingerprint of an invisible mass in the flowing patterns of everything around it, and found the Great Attractor not by looking at it, but by listening to what everything near it was trying to say. We stepped back further, and found that the Great Attractor is not alone, that it sits within something larger still, Laniakea, the supercluster, the spacious heaven, 500 million light-years of gravitational watershed, containing 100,000 galaxies in a single, coherent, slowly flowing structure. A cosmic home address more complete than anything we had before 2014. A name for the largest thing we belong to, before the scale of the cosmic web makes individual superclusters into mere nodes in a vaster network. And then the web itself, the largest structure in existence. Filaments of dark matter and luminous galaxies, stretching across hundreds of millions of light-years, woven into a 3-dimensional network of extraordinary complexity and extraordinary beauty. Matter flowing along the filaments toward the nodes. Voids emptying themselves into the surrounding structure. Everything in motion, everything connected, everything participating in the slow and continuous reorganization of the universe's matter according to the single, unchanging, infinitely patient logic of gravity. We stepped into the voids and found them not empty, but quiet. Not nothing, but a different kind of something. Sparse and dark and vast, threaded with the ghost traces of dark matter and the ancient microwave glow of the universe's birth, drained steadily by the surrounding gravity into the web around them. The silence between the notes. the necessary emptiness that gives the luminous filaments their shape and meaning. We discovered the invisible ocean. Dark matter, 27% of the universe, present everywhere but detectable nowhere directly, the scaffolding that was built before the lights came on, the riverbed along which the river of galaxies flows, the force that holds galaxies together against the centrifugal tendency of their own rotation, the hidden mass that makes the Great Attractor greater than anything visible alone could account for, the thing we know by what it does to everything we can see, and will perhaps never know by any more direct means. And then the counterforce, dark energy, 68% of the universe, dominant in the cosmic budget, responsible for the acceleration of space itself. The force that stretches the distances between things, that lengthens the river even as gravity tries to deepen it, that will eventually, over timescales so vast that our current age of the universe is barely a preface, thin the connections of the cosmic web and isolate each gravitationally bound island in its own expanding darkness. All of this we found. All of this we carried, piece by piece, through the quiet hours of this night. And now, in this final passage, I want to offer you one last thing. Not a fact, not a measurement, not a distance or a mass or a percentage of the cosmic energy budget. Something softer than that. Something that I hope will remain with you after the details have softened and the specific numbers have blurred at the edges in the way that things absorbed in near sleep sometimes do. A feeling. The feeling of what it is to know where you are. Not your address in the ordinary sense. Not the street and the city and the country on the particular planet you call home. But your address in the full and extraordinary sense. The complete coordinates of your existence in the cosmos, as best as human science has so far been able to determine them. You are on a rocky world orbiting a middle-aged star. That star occupies a position on one of the spiral arms of a galaxy of 400 billion stars, called the Milky Way. The Milky Way is one of dozens of galaxies in a gravitationally bound collection called the local group. The local group is part of the larger flow toward a massive concentration of matter called the Great Attractor. The Great Attractor is a feature of the supercluster called Laniakea, the spacious heaven, which spans 500 million light-years and contains 100,000 galaxies. Laniakea is a node in the cosmic web, the largest structure in the observable universe, a network of luminous filaments and vast dark voids stretching across the full breadth of everything we can see. And the cosmic web exists within a universe 13.8 billion years old, expanding under the influence of dark energy, structured by the invisible scaffolding of dark matter, flowing continuously under the influence of gravity toward an arrangement of matter and space and time that will not be finished for longer than we can honestly imagine. That is where you are. That is the full address. And somewhere within that address, at every level of it, in the motion of the Milky Way and the flow of the local group and the slow river of Laniakea moving toward its gravitational heart, there is a journey that was underway long before this planet formed, long before the sun ignited, long before the first living thing stirred in the first warm shallows of the early Earth. The Milky Way is moving toward a destination we still do not fully understand. I want to dwell in those words for a moment, not move past them, not soften them or resolve them into something tidier, because there is something remarkable in them, something worth keeping exactly as it is. We still do not fully understand, after all of it. After the careful measurements and the Nobel Prize-winning discoveries, and the supercomputer simulations, and the decades of patient observation, and the maps that span hundreds of millions of light-years. After everything that human intelligence and curiosity and ingenuity have managed to wrest from the darkness of the universe, we still do not fully understand the destination toward which our galaxy has been moving for billions of years. The Great Attractor remains, in important ways, mysterious. Its full mass distribution is not completely mapped. The structures beyond it, larger concentrations that may themselves be drawing the Great Attractor, Superstructures only beginning to be identified are still being studied, still being debated, still being slowly resolved from the noise of incomplete data and obstructed sight lines and instruments not yet quite powerful enough to see everything they are pointed at. The universe is not finished revealing itself, and that I want to suggest is not a source of frustration or inadequacy. It is a gift. A universe that had given up all its secrets would be a universe without surprise, without the particular quality of aliveness that comes from encountering something genuinely unknown, without the possibility of discovery, that extraordinary human experience of finding something real that no one has found before, of extending the map of knowledge by one more hard-won increment into the surrounding mystery. The Great Attractor keeps some of its secrets. Dark matter keeps its deepest nature. Dark energy keeps its fundamental identity. The full architecture of what lies beyond the observable horizon keeps its silence. And so the universe remains, after everything, a place of wonder. A place where knowing more leads not to the closing of questions, but to the opening of larger ones. Where every answered mystery reveals a surrounding context of deeper mystery. Where the map, however carefully drawn, always has edges, and beyond the edges, the unknown continues, vast and patient and full of things not yet named. We are moving towards something we do not fully understand. We have always been moving towards something we do not fully understand. And perhaps that is the most honest description of what it means to be alive in this universe. To be in motion. To be drawn by forces only partly visible toward destinations only partly known. To travel, as the Milky Way travels, and as we have traveled tonight, through the dark and the beautiful and the strange, not because the destination is certain, but because the pull is real, and the journey itself is full of things worth seeing. Let that be the last thing you carry from this night. Not anxiety about what is unknown. Not the vertigo of scale, or the disorientation of distances too large to hold. But the quieter, deeper, more sustaining feeling that comes from having looked at the universe honestly, and found it to be, for all its darkness, for all its mystery, for all the forces working at cross purposes across unimaginable scales, genuinely, unmistakably, extraordinary. The Great Attractor pulls. Dark matter holds its invisible shape through everything. Dark energy stretches space in every direction, slowly and without rest. The voids drain into the filaments. The filaments flow toward the nodes. The nodes gather matter into the deep gravitational basins of the superclusters. And the superclusters themselves move, within the vast and glowing web, in patterns still being mapped by human minds on a small rocky world, in one of 100,000 galaxies, in the spacious heaven of Laniakea. And somewhere in all of that impossibly small against the scale of it, and yet somehow, improbably, aware of the scale of it, you are here. Breathing. Resting. Held by the gravity of a world that formed from the same cosmic processes we have been tracing all night. Made of atoms forged in the interiors of stars that lived and died before our sun was born. Carried through the universe at 600 kilometers per second in a direction that the mathematics of galaxy motion has been trying to describe for decades. Part of the river, part of the web, part of the living, flowing, dark matter scaffold, dark energy stretched, gravity governed, ancient and ongoing and not yet finished universe that contains everything that has ever existed or will ever exist. You are part of it. You have always been part of it. And tonight, in the long quiet of this drift through the cosmos, I hope you have felt that, not just understood it, but felt it. In the way that things feel when they settle into the body, rather than remaining only in the mind. In the way that the largest truths sometimes do their deepest work not in the moments of waking attention, but in the threshold between waking and sleep, when the mind is soft and the defenses are down and the heart is open to being genuinely moved by something. The universe is moving. You are moving with it. You are safe in the dark. You are held in the web. You are drawn, gently and without ceasing, by a force that has been pulling since long before you were born, and will continue long after every star you can see has cooled to silence. The Great Attractor waits, patient as time itself. And you are on your way. You have always been on your way. Rest now. Let the river carry you. Let the web hold you. Let the dark be what it is, not empty, never empty, but full of the invisible architecture of everything that exists, threaded with ancient light, alive with the slow and gorgeous motion of a universe that is always, at every scale, doing something extraordinary. Let it all be there, enormous and patient and real, beyond the walls of this room, and the weight of this body, and the soft, settling rhythm of your breathing. And let yourself be here. Small, warm, aware, drifting through the spacious heaven at 600 kilometers per second. Going somewhere you don't yet fully understand. In the very best of company. Good night. Sleep well. The cosmos continues. And it is beautiful.